Yes, good evening, everyone. Yes, very good evening, everyone. Now, see, before starting the other topic, just I would like to revise the topic what you have taken yesterday. Here, sir, characteristics we have taken. One second. Wait for 1 minute. Right. Right. So I'm revising the topic now. Kindly concentrate here. Sir, we have taken characteristics in yesterday's class, right? Right. Now, after those, what we have taken, in yesterday's class, linearity, sensitivity, dead time, dead zone, right? And we have taken dynamic characteristics like which one? Speed of response, measuring lag, and fidelity. Right. See, I told you clearly in this, these are with respect to dynamic. Okay, right, sir. In this, generally people are already compared this here. Measuring lag and dead zone, dead time, both are same or not? No. This is there in which device I told you? In log instrument. Why? The pointer has to move. The pointer has to move from its initial position. It will be having small inertia. This is the inherent characteristics I told you. But measuring lag, what is measuring lag? This is the delay provided intentionally. Due to the delay, output will be varied from time to time. That's it is coming under dynamic characteristics. One thing. Second thing. One more doubt here is, I'm revising this topic. Fidelity. Sir, can we say static errors are zero, fidelity is good? I told you clearly, dynamic errors are not there. Then we can say fidelity is good or high fidelity. Means fidelity is a terminology only for dynamic conditions, not for static conditions. Clear? And one more thing here is, sir, I told you clearly, desirable. You are not understanding this word. Desirable means which are higher side, which are good side, right? Undesirable means which are lower side, which are poorer side, which are poorer side, right? I'm coming here. Accuracy must be high, right? Accuracy. Precision must be high, so desirable. Drift must be as low as possible. Drift is here. Hysteresis error must be as low as possible. Linearity must be always expected, so therefore linearity. Sensitivity must be high. Sensitivity. Here people are getting confused. Resolution. Resolution must be good. Means measurable value is small only, but the quality of measuring small values is called as good resolution. Good resolution means coming under desirable only. But don't think like the smallest measurable, so as small as possible, so undesirable. Not like that. If it is able to measure as small as possible, that is called as good resolution or high resolution or best resolution. That is what resolution here. And dead time and dead zone. Dead time and dead zone means it is in the operation, what is it? Some delay type of structure, but inherent delay, not the created delay. So that's why dead time or dead zone is here. And speed of response, no doubt, high. Here people are getting again, sir, you told that delay is required, still also I'm seeing delay is required, but undesirable. Undesirable is nothing but unwanted. No, not like that. Everything is required. All these characteristics are required. All these characteristics are required, but this must be lower side. So therefore, measuring lag. And fidelity. Fidelity means fidelity expected must be as high as possible. So therefore, fidelity is here. Simple logic. See, I don't know whether you know it or not. Generally, what we say, 6 months one time or 1 year one time, at least, generally we should get fever. The people will say, general idea I'm giving, at least 6 months one time or 1 year one time, at least we should get fever for one time, right? If that is coming, so unwanted things will be going out from body. Generally we say, just cold or cough or something, at least 6 months one time we should get. But see, we should get means, yes, what is that? We should get that fever and all means heavy fever, dangerously high or only small? Only small. So that's why fever we should get, but lower side, lesser side, poorer. That's what is called as undesirable. That's what the actual meaning. So no, that's why everything is required. Everything is required, but few things are required toward higher side, towards good side, towards best side. That is one category. Few things are required towards lower side, poorer side, or lesser side. That is undesirable, you can say. And one more thing. Here, people are asking the question, they send messages to my number also. Parallel combination. I have not taken the parallel combination so far. Today, I'm going to complete the error analysis, including special cases like parallel combinations. Special case like parallel combination, everything I'm going to take. Right? So this is the brief idea about the topic what we have taken in the yesterday's class. Just small idea here. Now, next continuation. So far, we have taken questions and all, right? Right. See, whatever the characteristics I told you, these are coming under which one? Static means these are static only, means for a given condition, those are constant. These are dynamic means these are dynamic only for a given condition. Also, those keep on getting changed. That's what the meaning. Okay, those are coming in static means those are by nature static only for a given structure. These are coming under dynamic means by nature these are coming under dynamic only. By nature, take it for granted. I told explanation, take it for granted. Okay, right. Now I'm taking the next topic. Concentrate here. Concentrate. Types of error. Types of errors. Sir, already we have taken, no? Yes, we have taken only two types of things. Static and dynamic notation we have taken. But now errors I'm going to classify based on how those are occurring, based on The concept, how those are occurring, how those can be minimized. Based on that, I'm defining the errors into three categories. There are three categories of errors, right? Concentrate. In the gate point of view, from this topic, numerical questions will be there. In the ESC paper, from this topic, objective questions are there. How? I'll tell you. So, first one is gross error. First one is gross error, right? Second one is instrumental error, or we can say actual notation is systematic error. Systematic error. And third one is random error. Random error. Okay, right. Sir, again, in this systematic error, there are three types again. One is instrumental error. Instrumental error. Second one is environmental error. And third one is observational error. This is a classification. In the objective point of view, means conceptual point of view, question is simply instrumental error comes under which category? Gross, systematic, random, some option will be given. Instrumental comes under systematic, like that. Which error comes under which category? That may be conceptual question. Okay, right. So let us define the errors. First of all, what do you mean by gross error? I'll tell you, don't answer anything, I'll tell you kindly, completely. Concentrate. Gross error. Sir, gross errors are defined as human being mistakes. Defined as human being mistakes. Means only human being mistakes, but operator mistakes are taken and considered as gross errors. That too. So human being mistakes means which mistakes? That's why be clear, everyone. If you take any measurement system, any measurement procedure, generally three steps are possible in general. One is, first you have to observe the device. If device is there, you have to observe the device. So therefore, observation you have to do first. Means where is the pointer located, 4.1, 4. Like that. Observation. After observation, you will write on the paper or notebook or something value, that is recording or noting down the value, we can say. After that, suppose you are measuring the voltage, you observe the voltmeter and 4.5 something, etc. You're writing. After that, you need to calculate power V into I or resistance V by I, like that. So therefore, in the calculation, totally there will be three steps will be there. Generally, in a laboratory also, you have done these three steps only. You have done one experiment, INR, electrical people. You have done the experiment. By wearing something, you observe the meters, observation. You noted down the values in the observation or record book, noted. After that, calculation. Torque may be calculated, force may be calculated, voltage may be calculated, speed may be like that. Multiplication, multiply, divide, etc., etc. So therefore, these three steps are commonly present in any measurement system. Suppose if the mistake is happened by the human being in observation, in recording, in calculation, that error is called as gross error. Gross means, what is the normal meaning of gross here? Gross means including everything. Gross means including everything. That is called as gross error. Okay, so that's why mistakes in observation, in recording, and in calculating the corresponding value. If this type of problem is there, this type of mistake is there, this type of error is there, that is called as gross error. That is called as gross error. So what is the definition? Gross errors are only due to the mistakes of human being. Due to the mistakes of human being, that too in which steps? Only three steps. Of course, only three steps are there. Observation, some mistake means, suppose my eyesight is not good, for example. I may be observing 4.2 instead of 4.1. That is a common mistake. Yes or no? And suppose 4.65 is noted down, for example, observed, for example, while you're writing something, 4.65, why? Okay, let me write 4.6 or 4.7, like that. Some round figure, that is also one. And calculation, while you're calculating also, some wrong calculation. Maybe, I'm not saying that compulsory, may be possible. So those type of errors are called as gross errors. Okay, now come to this. So these are called as gross errors. Okay, how do we minimize those? Very, very simple topic here. How do we minimize these errors? Means human being should take more care. Human being should take more care in observation, in recording, and in calculating. Human being should take more care in observation, in recording, and in calculating. Means more care is required. Yes, minimize it. But can you eliminate it? No. No one error can be eliminated here. Our duty is to minimize. Yes, minimization. Okay, right. Come to the next one. Sir, instrumental error. Sir, what is instrumental error? Means simply misuse of instrument. Misuse of instrument. This is generally comes under instrumental error category. Sir, what do you mean by misuse? What do you mean by misuse? Means here, wrong connection may be there. Wrong connection. Sir, what do you mean by wrong connection? First one. Sir, ammeter must be connected in series. Voltmeter must be connected in parallel. Right? So therefore, suppose ammeter in parallel, wrong connection. Suppose voltmeter in series, wrong connection. If you are having this wrong connection, due to this wrong connection, we get some error. Yes or no? This type of error is coming under instrumental category, instrumental error category. Due to this wrong connection, the ammeter may be damaged or the corresponding meters may be damaged. As the meters are getting damaged, those will be definitely showing the wrong readings. That type of errors, that type of wrong readings obtaining position is called as misusing of instrument. One thing. Sir, misuse means not only this, something else is also there. What is that? Suppose, concentrate. Here, I want to connect, this is A, this is B, this is C, for example. Generally, this is the general mistake happened in the laboratory generally. Sir, I want to connect ABC terminals. Okay, right. If I want to connect ABC together, ABC all together at one place, how many wires mean? Generally, sir, here to here I'm connecting one thing, here to here I'm connecting one thing. It is sufficient actually. It is sufficient. But few people, by getting confused, they're connecting one more wire from here to here. Is it required? Not required. Why? My task is ABC terminals, 3 must be connected together. Yes, connected together. This wire is not required. Suppose if you are connecting the extra connecting wires, this is very, very, very common problem in the laboratory. Generally, I don't know in a laboratory how it is a procedure. See, one experiment is there. This is panel board and this is some table, for example, like this is there. Okay, to this table one draw will be there. In that draw, the connecting wires or connecting probes will be placed. How do we place? The connecting probes must be counted. 10 connecting probes for this experiment means if you use these wires properly, 10 wires are sufficient. But if you're going like this wrong connection, extra wire you require. Suppose if you're connecting like this means somewhere else in the other connection, you are missing one wire. Yes or no? If you're missing one wire, we don't give that. In the laboratory, we don't give extra wires also. That's what actual thing related to the laboratory performance. But nowadays, what is happening, in one cotton box, so many hundreds of wires will be there. People will be taking as many as they want. If you are doing like that, automatically there may be a chance of connecting extra wires. If you're connecting extra wires, automatically at this point, extra joint is happening. If extra joint is happening due to this wire, extra drop will be there. Due to that extra drop, definitely some error will be there. Or yes, this error also possible. That's why it is also, what is it here? Misuse of instruments. Instrument means connection, everything, misuse. Next, one more mistake, see, I don't know, generally electrical people are having one statement like, in the laboratory, faculties are shortest faculties. Faculties are very serious, like that, generally. Yes or no? Right. In the laboratory, what faculty does means, suppose in one lab is there, right? You are given the connection. Example, machines lab. You are given one connection. The moment you are giving the connections, you cannot switch on the supply directly. I don't know about what your college, but generally this is a procedure. After giving the connections, everything by you, your friend's batch, you need to call the person, either faculty or lab assistant, etc. What they do first, by coming over there, they will pull the wires like this. They will pull the wires like this. Immediately you will get the so much angry on them. We have taken much time to connect, but this fellow is coming and pulling. You will scold them. That is natural, actually. That is natural. At Vishnu Ajit, 90% are psycho, sir, not sadist. Okay. See, psycho, actually, I should not say that word. You should not say, because that is for advantage purpose. That only I'm going to show. See, if they are pulling the wires, you may be thinking like that person is psycho or etc. etc. No, yeah, actually for your safety only the faculty does like that, because the moment we are pulling like this, if any wire is coming out, that is called as loose connection. That is called a loose connection. Suppose by unknowingly, if you have the, okay, without looking any circuit connection, etc., if we give the green signal like, yeah, go ahead, switch on the supply. Suppose after giving the supply, if you're taking the reading, etc., that supply is on, that wire is coming and touching you, what will happen here? Human being hazardous will be there. That is the reason why. Generally faculty does. Okay, other people, other faculty, I don't want to comment here, but generally the main purpose is for this only. So that's why loose connection also very good. Dashrath Reddy, very good, that I'm giving. What is it? Loose connections must be avoided, otherwise small sparking will be there. You may be observing, you may not be observing. Sometimes due to sparking, experimentally speaking, errors will be there. Practically speaking, it may be dangerous to human being, it may be dangerous to operator. That is the reason why intentionally we do. But sir, other lab we don't do, means in other lab what is the value here? In ECE lab, generally we go to ECE lab, etc. How much power they will use here? ECE people especially, they use MW. Generally in the practical field, milli they will use. But what is electric? It means instrumentation, you are coming at electrical branch only. We will be using capital M. In the practical electrical fields, can we say both are same? May I take it like? No. That's why in other laboratories, that much serious is not required, because milliwatts, milliampere, milliwatts of power, not that much. But here in our laboratory, 13 amperes current also flowing. 230 volts is there. AC three-phase machine is 400 volts will be there. 1 kilowatt load, 2 kilowatt load, 10 kilowatt load also will be there. Can we leave them just like that here? Definitely no. That is the reason why in our laboratory, means generally in our measurements lab or machines lab, etc., etc., you need to take more care in misuse of instrument. Means not only series to parallel, parallel to series mistake. No, wires connection also we need to concentrate. We should not connect more than the required wires, and we should not connect overlapping. We should not go for loose connections also. We should not go for loose connections also. Clear? Right? Right. Next. And this is what misuse of instrument. Second thing, right? Okay, before going to second thing, sir, how can we minimize? Means very simple. Whatever the connection given by the operator or whoever is giving the connections, they have to, he or she has to take more care. He or she has to take more care in connection of ammeter, that is in series, voltmeter in parallel, without overlapping connections, without loose connection. If you take more care, thing will be done. No problem. You can minimize the errors. Still error will be there, but you can minimize it. Next, second one, inherent shortcoming. Inherent shortcoming of instruments. Inherent shortcoming of instruments. Sir, what does it mean? Means by the construction itself. Means suppose we are purchasing the device. Actually procedure is once you take the device, they have to come and they have to check every device and they have to give the demo generally. But if you're taking 10-20 devices, sometimes 1 or 2 devices will be checked, other devices may not be checked. Suppose you have not checked one device. Suppose internally from the manufacturer side only some damage might be there, some wire might be broken internally, etc. Due to that problem also, do you get corresponding proper value? No, error. That is called as inherent shortcoming of instrument. Means from the manufacturer side only, from the manufacturer side only, improper construction we can say. If it is having improper construction, automatically we cannot get the best readings automatically. Clear? Right, sir. This is one thing. So how to overcome this means, sir, before taking the instrument must be checked. Means supply should be given, pointer is moving properly or not, any internal problem is there or open circuit is there, etc, etc, all must be checked. If you check like that, automatically that error can be minimized, not completely eliminated but minimized. Okay, next, third one is loading effect. We can say very important point. Instrumentation people have taken the transducers loading effect. That is, this is second time revision for you. But electrical people, loading effect, this is the first time to you, kindly consider. Loading effect means it is the concept of error. Loading effect or loading error, like that, everything is same. Error due to internal resistance of the meter, nothing but in the meter. Definitely, in order to have the flow of current and all in the meter, definitely a coil should be there, no, right? Conductor should be there, no? Yes, in that coil, whatever the resistance is there, that resistance also gives some error. Definitely that is compulsory, but that error must be as minimum as possible. Suppose due to the internal resistance of the corresponding device or internal impedance also, we can say impedance or resistance of the device. If the error is more, what we can say, loading error is more or loading effect is more, we should say. Loading error is more or loading effect is more. So that's why the manufacturer should design the devices perfectly, such that instrument internal resistance should give the less error, So my question is, sir, instrument internal resistance should give the less error. Okay, sir, ammeter internal resistance must be high or low. Voltmeter internal resistance must be high or low. Means be clear. I'll prove it within a few minutes, don't worry. Ammeter internal resistance must be as low as possible. Ammeter internal resistance must be as low as possible. Means minimum internal resistance should be there to get the less error. Why? I'll prove it later, no problem. And voltmeter internal resistance must be as high as possible to get the as low as possible error. Clear? And generally people say that, sir, here internal resistance is 0. 0 means ideal case. Ultimate internal resistance is infinite, means ideal case. But I'm asking about practical case. So practical means always ammeter should be having as less as possible internal resistance. Voltmeter should have as high as possible internal resistance. Right? Why also I'll prove. But you know this generally. I'm going to prove that only here, right? After explanation of loading effect, I'll be coming to environmental error and observational and random error later. Now I'm taking loading effect. This is the electrical gate instrumentation, ESC electrical previous question model. Based on this, previous question is there. So concentrate. So I'm taking here loading effect. I'm taking loading effect. So what is loading effect? I told you, error due to internal resistance of the meter. Error due to internal resistance of the meter. Okay, right. Now I'm taking one numerical example. I'm explaining the concept with the numerical example. Concentrate. Sir, first case I'm taking, ideal case I'm taking. Sir, ideal case means we are going to get true value or practical. True value or measured value means ideal means error will not be there. Whatever we get, that is true value. That's what I take. Okay. Sir, I'm taking randomly one circuit here. Suppose one resistance and one resistance is there. Here, one voltage source is there. Suppose this voltage source is 35 volt. This resistance is 600 ohm, right? And voltage across this observed as 5 volt. Then find the value of R. This is what the question. What is the question here? If the voltage across 600 ohms is 5 volt, then find the value of resistance R. Then find the value of resistance R. This is what the question. Clear? Right. Sir, why it is ideal also I'll give you. Why it is ideal also I'll give you. Right. Concentrate here. Sir, first let us have the mathematics first. Sir, across 600 ohm, 5 volts is there means what will be the value across the R? Automatically 30 volt will be there. Okay. Let us apply the voltage division law. What is the voltage division law here? Sir, 30 is equal to 35 into 30 is equal to total voltage into where you are finding across R by sum of these two, voltage division law. Okay, now I'm taking here. Sir, 30R is equal to 30R plus, what is it? 18,000 is equal to 35R. So therefore, 5R is equal to 18,000. R is equal to, what is it? 3.6 kilo ohm. 3.6 kilo ohm. Clear? Right? Okay, sir. Why it is called as, how it is called as, see, why it is called as, or how it is called as, concentrate here. Ideal case only, so that I can say this as the true value, means concentrate. Sir, how do you measure the voltage? With the voltmeter only. But have I shown the voltmeter here? No. Means actually here voltmeter is there. Here voltmeter is there. But voltmeter is not shown here. Means open circuit structure is shown. Means voltmeter has infinite resistance. Yes or no? Voltmeter with infinite resistance symbolically, or you are removing this also, no problem at all. Both are one and the same. Infinity resistance means simply open circuit. So therefore, under open circuit is there means voltmeter is there, but infinite resistance is there. Then we are getting this value, means this is the value observed in the circuit or obtained in the circuit with the help of infinite resistance of the voltmeter. With the help of infinite resistance of the voltmeter. That's why simply true case. Okay. Still any doubt is there? Kindly, it will be clarified now. Right. So second one, practical case. Practical case. Right. Sir, what is practical? Right. Sir, practical case. So in this practical again, for more clarity purpose, I'm taking two parts here. In the first part, concentrate. I'm taking same circuit only here. This is 35 volt. This is 600 ohm. Right? Here, R value, but concentrate here. Here, I'm connecting a voltmeter. I'm connecting a voltmeter of 2400 ohm, means 2.4 kilo. Now this voltmeter reads 5 volt. This voltmeter reads 5 volt. That's what the point. Now what is my question? Find out resistance value. Sir, earlier case voltmeter with infinite resistance was there. That's why whatever the process, whatever the value, that is ideal value, true value I told. But now, sir, voltmeter with finite resistance. Voltmeter with finite resistance means this is Which value? Practical value. Sir, practically we are getting means which value? Measured value. Okay, right, sir. You need to understand one point here. Network theory is done or not done, I don't know. Just concentrate here. That's why I'm explaining all the things. So 5 volts is only across the voltmeter, or only across the 600 ohm, or across the parallel combination. Means 5 volts is the voltage across parallel combination, because parallel voltage will be same. Clear? Okay, sir. Across this 5 volts is there means automatically across this 30 volt will be there. Again apply the voltage division, sir. 30 is equal to 35 into, you're finding the voltage here R by R plus, what is this total value? That is 6000 parallel with 2400. Clear? Now kindly mathematics only simplify this. I'll give the value. You will be getting 2.88 kilo ohm. 2.88 kilo ohm. Sir, here 3.6 kilo we have got it. Here 2.88. But sir, this is measured value or true value. This is measured by we are using practical voltmeter. So with this, whatever the value you're getting, that is measured value only. So measured one I'm taking because case one. Okay, thing will be done, but for idea purpose, I'm giving one more one. But idea purpose, I'm giving one more notation. Sir, second case, in this only second case I'm taking. Which one? Practical only second case. With some other value I'm taking. What is that? Sir, resistance is there. Resistance is there. And here, like this. Sir, this is 35 volt. This is 600 ohm. Same thing. Now, I'm connecting a voltmeter of some other resistance. What is that? For example, 1200 ohm, for example. You can take anything. I'm taking 1200 ohm. So across this, still it is showing 5 volt. Suppose if it is still showing 5 volt, find out the value of R. Here people are getting small doubt. Sir, in this also it is showing 5. In this also, how does it show? Concentrate. What is my question? If this voltmeter shows 5 volt, what is the value of R? If this voltmeter shows 5 volt, what is the value of R? That is what the question. Therefore, the question itself is, if it shows 5 volt, what is the value of R? We need to find out. Right? Now, the second case in this, sir, voltmeter with finite resistance. Sir, voltmeter with finite resistance means automatically what's it? Measured value only. So therefore, okay, sir, across this parallel 5 volts is there. Sir, 30 volt is here. Okay, same procedure. Sir, 30 is equal to 35 into R by R plus parallel combination of these two. What is it? 1200 parallel with 600. You'll get 400 here. If you simplify this, you will be getting R value as 2400 kilo ohm or 2.4 kilo ohms. It is also measured value only, but this is a second measured value. Why? Two cases I'm taking. One practical, second practical. One and second practical. Okay? Now, with all these things, now I'm giving the summary. Now I'm giving the conclusion. So far, we have taken only mathematics. What we have taken here? Simple voltage division law. Here, find out the value of R. Got it. Find out the value of R. Got it. Here also find out the value of R. Got it. Sorry, one second. Yeah. 2400, 2.4 kilo. 2400, 2.4 kilo ohms. Clear? Right, sir. Now conclusion. Sir, here I'm writing first one. Here I'm writing first one. Sir, what is it first one? Concentrate. Here, R true value. R true value is 3.6 kilo ohm. Okay. Next, R measured one is 2.88 kilo ohm. Okay. R measured 2 is 2.4 kilo ohm. Okay, right. Sir, what is error? Therefore, error 1. Error 1 means I'm taking this one. What is that? 2.88k minus 3.6k. Value only I'm taking. Error 1. What is that? Approximately, what is it here? Minus 0.72k. Clear? Minus 0.72k. Okay. Sir, what is the error 2? Error 2 is which one? Measured value 2.4k minus 3.6k. So minus 1.2 kilo. This is what the answer. Now tell me, which case error is more? Second case error is more or first case error is more? Obviously, second case error is more. Now tell me, sir, second case error is more, first case error is less, means what does it mean? Concentrate. Sir, in the second case, what is it here? Voltmeter with 1200 ohms only you kept. If voltmeter with 1200 ohms is there in this question, what is the error? 1200 ohms is the error, minus okay. But if you are coming from voltmeter with 1200 ohm to voltmeter with 2400 ohm, error is reduced from 1200 to 720 approximately. Yes or no? Okay. Next, sir, voltmeter with 2400 ohms to ideal voltmeter mean infinity I'm coming. Error is becoming zero. True. Means with this entire discussion, voltmeter with high resistance gives the less error. Voltmeter with less resistance gives the more error. So that's why, see, 1200 is more only, but 1200 compared to 2400 is less in magnitude. That is the reason why. What we can say now, therefore, what we can get here? Therefore, voltmeter should be designed with voltmeter should be designed with as high as possible internal resistance to get less loading effect, or to get less loading error also we can say. That's why I told you here, voltmeter should be designed with as high as possible. Why means practically, numerically I'm showing like this. So therefore, voltmeter should be designed with very high resistance. Clear? Clear? If the voltmeter is having high resistance, automatically it will give less error. Clear? Right? So this is the total discussion regarding error analysis with respect to which one here? Instrumental error category, that is loading effect. That's why I'm coming again. So how do you minimize this? Means human being, nothing but operator should take more care in observation, in recording, in calculation. And how do you minimize this? Means same thing. This one which one here? Operator should take more care in connection of the instrument, in connection of the wires, in loose connection, etc. Operator should take more care. Next, inherent shortcoming. How can we minimize this? Before taking the instrument from the manufacturer, you need to test it. Simple logic. You need to test it by giving some supply, working properly or not. Simple. But how do you minimize the loading effect? Means we cannot give the generalized statement because ammeters are there, voltmeters are there. Wattmeters I'll tell you later. I'm talking about only ammeter and voltmeter. Voltmeter should be designed with as high as possible internal resistance so that error will be less. In the same way, ammeter is reverse case. But don't worry, one example I gave you here after a few topics, ammeter example also will be given, don't worry. But everyone knows this, take it for granted. But in my subject, I will prove it again. Ammeter must be designed with as high as possible internal resistance compulsory. That's the point. Okay. Now this is about total instrumental. Instrumental error is somewhat lengthy topic among these three topics. After that, very simple concept. Again, conceptual thing. Sir, what is environmental error? Sir, what is environmental error? Environmental error, very simple. Yeah, due to change in due to change in temperature, right? Atmospheric temperature, we can see pressure, right? Or humidity, etc. If we are having these changes automatically instrument will give different readings. Not only human being here, different readings the device will give. The best example is your computer's lab. In the computer's lab in your college, definitely ACs were on or off. ACs were on. Suppose if ACs are off, the computer will be hanged up, we can say. Means based on the temperature change, those will not work properly. Simplest example. That's why we also same thing. We also same thing. Full of cold is there, our mind will not work properly. Full of heat is there, will not work. That's why particular temperature. That's why not only human being, instruments are also of the same category. Due to the change in temperature, due to the change in temperature, definitely error will be there. Error will be definitely available. So therefore, my question is, sir, outside atmosphere is changing. Outside atmosphere is changing means outside field will be changing. Everyone knows that surrounded by me, surrounded by you, magnetic field is there in the practical world or not? Yes. Therefore, as the temperatures are getting changed, those fields will be getting changed. Therefore, those fields effect on the instrument will be changing. Automatically, meter reading will be changing. That's why, due to the environmental factors, the effect on the instrument from the outside atmosphere will be changing automatically. Due to that, correspondingly errors will be. That is the reason why what we say always, for a given particular atmospheric condition we say. Otherwise we say like this, sir, at a room temperature means, what do you mean the room temperature? Which one is the room temperature? 25 to 22 to 35 approximately, not exactly. Whatever be the temperature, we can treat everything as a room temperature only. But strictly speaking, as this temperature is getting changed in 22 to 35, definitely behavior properties of the instrument will be changing or not. Due to that, error will be changing or not. But that will be taken as negligible error. Why? At a room temperature means at a particular, but can you maintain exactly 20 degrees, exactly 26 like that? No, that will be keep on getting changed. That's why normally what we say, while we are operating the instrument for a particular temperature, we should say. That's why what you have to say now, while we are measuring, we need to maintain a particular temperature, particular environmental condition we say, but slightly will be changing. No one can modify that. That is commonly present. That's why in our measurement subject, errors are commonly present, but our duty is to, as minimum as possible error we should get. That is what our duty. But don't think like I will eliminate. No one can eliminate. That's not the point, right? How do you minimize means maintain the proper environmental conditions, suitable environmental conditions. Okay, next, observational error. Everyone, very simple example. Observational error example is parallax error. We say parallax error. Sir, what is parallax error? Means everyone knows that in the observation mistake. Suppose, concentrate. This is a analog instrument. For example, analog instrument is there. This is the pointer. This is a pointer, right? My pen is the pointer. Suppose this instrument is like this. I am standing this side of the instrument. You people are standing other side of the instrument, right? Some other person standing exactly in front of the instrument. Who will observe the value properly? Means the person who is standing in front of the instrument. The person who is standing in front of the instrument. Okay, right. Suppose if I am observing from this side, definitely due to this pointer shadow, definitely I may be observing the wrong date. Suppose it is showing 1, but I may be observing 1.1, etc. Chance is there. Suppose that side person is observing, he may be observing due to this shadow 0.10 or something. But who will observe one as a one perfectly means those who are observing exactly like this, that person will observe. That's why if you are not having the proper position with the measuring instrument, whatever the error comes into picture is called as parallax error. That is the example of observational error. That's why here one thing I'll tell you. Generally in your college, while while giving, while you are doing the experiment in your college, 5 members, 6 members will be there. Generally, 5 members will be there. 5 members will be there. Yes or no? Out of 5 members, 4 members will do the experiment generally. One person duty always roaming around the corresponding laboratory. I hope our experiment completed or not. Yes, then that person will come and writing the value. That is different. Okay, but my question is, out of those 4 people, also, I have seen many people. The meter will be here. The meter will be here. One person will be standing over here. Take 1.2. Not I have to take 1.2. Take 2.2. Come on, take 1.2. Like that they will say. Finally, they are taking, means device is somewhere else. Table is long distance. Yeah, okay. Take 1.2. Like that the people say. But you said like that, you have taken the readings and you got one machine is there, for example, DC machine is there. Suppose you are doing the experiment. Okay, all the values you noted down. If you're finding the efficiency, you will get 60% efficiency. But while you're studying the DC machines concept by the DC machine faculty, what did you study? DC machine efficiency is 70 to 75. But you get 60 only. What do? You'll blame the machine. Our college people did not bring the corresponding quality machine. It is a poor quality machine. It is giving the wrong answer. Come on here. Whose mistake? Our mistake only. Operator mistake only. Because the moment we enter into the lab, right, the starting of experiment to ending of experiment, we do so many mistakes. What is that? I told you already. Misuse of instrument may be there. Wrong connections may be there. Overlapping connections may be there. So many mistakes we do. Finally, we get the wrong result. Finally, we get the wrong result. Then we say a machine is not working good. Instrument is bad. Or come on here. Mistake is from our side. So that's why instrument. See, generally in every class, one student will be there who will observe the value like this. Is that no? Some student will be there. Immediately we do like this while you're doing. Come on, take some value. What is our duty? We don't take the value properly. We don't let our friends take the value properly. That is what the BTech lab category. I've seen so many students. You also did same thing. That's why who is correct means whoever is observing the instrument like this properly, he will get or she will get perfect value. That is what the correct. That's why, because of all these mistakes, generally in the laboratory, you might have got 60 or 65. Theoretically, you study around 75. Why it is not coming means all the mistakes. That's why in the college laboratory, only to understand the concept, the laboratories will be there. Not to have real-time experience. What is that? Okay, if I increases, it has to decrease. Decreasing or not, that is enough. But which value decreasing, that will be there in the what is the real-time world. When you enter into the job field, then you will get. That's why whatever the laboratories are there in your laboratory, in your college, those must be attended properly by you compulsory, right? Generally, 95% of the people attend the laboratory for attendance only, because 3 hours, 3 periods will be there. That is the main problem. Are you clear? So that is the reason why. What is it here? If you would have done the experiments properly, what are the things I'm explaining? Everything will be coming in front of your picture, definitely. Because all these are the things you have done in your laboratory compulsory, no doubt at all. That's why. What is it here? Here in the parallax error notation, what is it here? Definitely this will be the position of the instrument. Otherwise you will get the error. One thing. Second thing, what I told you, how to minimize the error means you need to keep the device, you need to place the device exactly in front of you. Exactly in front of you, you need to place. That is one thing. Second thing, from manufacturer side, one more thing is also there. That is what? Mirror arrangement. Nothing but I don't know how many of you remember the instrument shape. I don't know. But if you observe the device properly, pointer will be there. And pointer will be there. Here, this my hand is white color paper, white color sheet you are observing. Between those two, some mirror type arrangement will be placed. That mirror will be avoiding the shadow effect. Means whatever the shadow is there, no, due to that mirror effect, shadow will be vanished. Therefore, we can get the value properly. But even though that is there, shadow and everything will not be completely eliminated. Therefore, even the mirror is there, little bit chance is there, to get the wrong read. That's why even though mirror, some glass type arrangement will be there in that, even though that is there, I'm requesting everyone to observe like this one. I don't know which you are pursuing now. At least if you are pursuing third year or fourth year, etc. Suppose if you go to the college, definitely in the laboratory, observe the values like this only, so that you can avoid the observational error. Okay, now people's million dollar question is, sir, observation, what is the difference? I told you clearly here, observation mistake plus recording mistake plus calculation mistake is there, then only it is combinedly called as gross. Gross means not only observation. Where are you comparing? No need to compare. Gross means observation plus recording plus calculation. All the three mistakes should be there, then only gross. Otherwise, suppose people are saying that, sir, mistake is there only due to these two. That is not gross. What we should say? Mistake is due to observation and recording. That's it. Okay, mistake is due to only observation calculation. That is not gross error. That's why I'm repeatedly saying all three mistakes should be there. That's why gross. So what is the meaning of gross? Gross means combination of everything. Gross means including everything. Generally say in our engineering also, gross power generated minus some losses, net power delivered, or gross salary minus some cuttings will be the net home salary. Means gross means including everything. That's why observation plus recording plus calculation, if three are there, then only we should say gross. If only observation is there, that comes under observational error, that is parallax error. Yes. Now this is the total discussion regarding corresponding errors and corresponding minimization of errors. Right? Okay. Clear, guys? Right. Now the very important topic for in the today's session is, of course, everything is important only. Right. The point here is, sir, random error. Sir, what is random error? Be clear, guys. Be clear. So what is random error? Right. What is random error? Sir, very important concept. The name itself indicates random, randomly changing. Sir, if any error is randomly, zigzagly changing, can you expect that error? Can you predict that error? If this error is because of this reason, because of that reason, can you expect like that error? No, that type of errors are called as random errors. What is it? Here, the error which cannot be predicted. The error which cannot be predicted. That error is called as random error. But here people are saying that, sir, what is the example for random? The definition itself is, what is it? The error which cannot be predicted means a particular reason, particular example cannot be given. That type of errors are called as random errors. Try to understand the error which is zigzagly, randomly changing without any reason will be there, but with a particular reason we cannot say, randomly zigzagly changing. That is the reason why it is called as random error. One thing, sir, in this we know the reason. We have taken the minimization method. We know the reason. Everywhere we know the reason, and we have taken the minimization methods. Okay. Now my question is, sir, we don't know the reason. How can we minimize the error? How can we analyze the error? Means concentrate. In order to analyze these random errors, we need to have random error analysis. Random error analysis. That is given by Gauss. Gauss is a scientist. He has given one random error analysis. So that error analysis is called as random error analysis. That is nothing but mathematical analysis of random error. Clear? Clear, guys? So therefore, what we can say, Gaussian, right? Mathematical analysis. Gaussian mathematical analysis. Gaussian mathematical analysis. Right. See, many people told that, sir, few people are disturbing you continuously. Can you don't concentrate? We are getting disturbed. Yes, I know. That's why if anyone is typing the questions continuously, irrelevant questions, I'm remembering their name. I don't answer your question. In the doubt session also, remember carefully. Otherwise, you're not listening. And keep on explaining. Few people are typing 3 to 4 lines of question. Means you're missing this topic. Again, in the doubt session, sir, explain the random error, sir. You're asking like this. So that's why I did not ask any questions so far. Why did you type? Why are you typing anything? Right? So that's why be clear. Don't type. See, just now I have started the random. Sir, where the random error occurs, people are asking. Kindly listen carefully. Gaussian mathematical analysis, that is called as random error analysis. So now the point here is, sir, what is this analysis? What is this analysis? I already told you the error which cannot be predicted, but still people are asking that, sir, where do we get it? That's what I told you. Where do we get it? When do we get it? Why do we get it? How do we get it? Everything cannot be given. The experimental based, we can understand that, okay, values are randomly changing. Yes, random error is there. So that's why be clear. Random errors which cannot be predicted. And this general doubt, people are asking that, so how can we expect it? You cannot expect, I'm saying here. That is what called as random error. But how do we analyze? Yes, I can explain. Be clear, guys, be clear. The point here is, while you are doing the experiment, suppose if you are getting the analysis like this, some instrument, right? X is given, okay? Sir, it is showing 1.9. Okay, leave it. Again, same X is given, 1.8. Chance is there because it is not the static now, it is randomly, zigzagly changing. With which reason? We don't know. It may be environment, it may be something, combination, zigzagly, anything may be happened. Okay, immediately, next number may be 2.4. Chance may be there. And 1.6. Again, 3 point, like this suppose happening. Sir, by observing this, can't we understand that the instrument is having the random error in this condition, in this atmospheric, in this condition at a particular given data? Yes or no? So therefore, what you can understand, 1.9 to 1.8, small drop. 1.8 to 2.4, sudden incremental. 2.4 to 1.6, sudden drop. Again, like that, zigzagly changing. Then that type of error is called as random error. That's why, as there is no particular conceptual reason for the random error, we need to depend one and only one method, that is called as mathematical method. That's why electrical engineers and instrumentation engineers should be very much perfect in the mathematics, because in the engineering field, 50%, 40 to 50% of the topics for which we cannot give them, what is it? Conceptual explanation. We can give experimental analysis, mathematical analysis only. That is the reason why mathematical analysis is being taken in this random error analysis completely. Okay, what is it random error? That too, who has given this? Gauss is a scientist. He has given this analysis. So therefore, Gaussian statistical analysis says that step by step I'm giving. Sir, this is the experiment here. I need to find out random error in the instrument. Value I need to find out. We know random error is there, but with which reason we don't know. Actually, don't try to get the reason, because we don't get it. Everyone, forget about it. So how to get it, why to get it, when to get it, forget about it. That is what randomly happening, unexpected error. How do you expect it? Unexpected error, how do you expect it? Are you getting? So that is the reason why. Kindly concentrate here. Sir, readings are there is exactly randomly changing. Okay, but sir, how do you get the error? Means he has given mathematical analysis. What is that? Experimentally proved analysis he has given. I'll tell you one by one. First one, sir, in order to get the error, we need to calculate this true value or not? Yes, sir. My question is, sir, how do we get the true value? That's why who has given here? Gauss has given one thing, that first in the random error analysis, first step, find the mean value. Find the mean value of all the observations. 1, 2, 3, 4, 5 in my experiment. It may be 10, it may be 20, 15, 25, etc. etc. Actually, openly speaking, whatever the thing I'm going to take for the next 5 to 10 minutes, that already you know in your mathematics subject. But you studied as the mathematical language. Now I'm converting the same mathematics into my measurement language. That's it. Other than that, everything you know already. Mathematicians, you know already. What is that? So find out the mean value. Means he is saying that. Who is saying? Gauss. Why? Means his theory only. What is it? X1 plus X2 plus X3 plus so on Xn by n. Everyone knows this. Very, very simple. Mean value is very general common topic. Okay. After that, terminology I'm converting into measurement language. What is that? Where X1, X2, so on, Xn are. In your mathematics, you say these are variables, you say, mathematical language. But in our logic, what is it? X1, X2, X3, X4, X5, X6, like that. What are those? Are measured values. So these are measured values. Okay, right. Second one. Sir, what is N? N means number of variables is the language in your mathematics subject. Here, number of measured values over. And what he has given theory, the two, based on the Gaussian theory only. Nowadays, all the practical world concepts are available. That's why for what are the practical random theories are there, that is by Gauss only. Just like Faraday's law is origin. No, in the same way, in this topic, Gauss theory is the origin. And he told that, sir, treat the X bar as the true value. Treat the X bar as the true value. Here, so many doubts will be into picture. So it is not true value. It is not true value, but treat that as true value. What is his theory? As we can't get the exact value, better approximate value must be treated as exact equivalent value. That's why treat this as a true value. That's why first is what is it? Take the experiment 5 times, 10 times, 20 as you wish. After taking that, take the average, mean value. Whatever the mean value you are getting, that mean value you should take as which value? True value. Okay. Sir, first step. Sir, I'm taking average. Don't take average value, just randomly. Take the average value. Assume that 2 is there. Don't calculate and don't say, sir, this is not 2. Example I'm giving. 2 is there. Sir, okay, true value is 2. Okay. First step, according to the Gaussian theory, true value we observed, we obtained, we can say. Okay. Sir, what is our duty? Not only true value, our duty is to give random error value. Our duty is to give random error value. That's why concentrate. Sir, this is measured value. Can we say 1.9 minus 2 is the random error always present? No, yeah. Random error means it is keep on getting changed. That's why we cannot take this measured value or this or this or this, etc. We cannot. That's why he has given continuation process. What is that? Second step. He is suggesting us to find out deviation. Deviation. Sir, what is a deviation? Means, see, n number of observed measured values are there, one true value is there. So therefore, here deviation 1, measured 1 minus true value. Right? Normal procedure. Deviation 2, measured 2 minus true value. So on. Deviation n, measured n minus true value. Only deviations he is asking us to determine. Okay. After that, what he has given, concentrate. Third step, find out the standard deviation. Find out the standard deviation. Right? Slowly, are you able to understand? Okay, we have seen this topic somewhere else. That is in the mathematics. That is in the mathematics. So therefore, standard deviation. It is denoted with sigma. Standard deviation. It is denoted with sigma symbol. What is the formula? I think you might have forgotten. Don't worry. I'll give the formula. Here, what is that? Standard deviation formula is d1 square plus d2 square plus so on dn square. This what? D1, D2, D3, so on is there? No, take it by n, by n. Clear? So this is the formula. And in this again, I don't know you are able to recollect this mathematics or not, but follow this measurement topic. Sir, this is the formula to be used when, and he has given one more formula also. He has given one more formula also, that is d1 square plus d2 square plus so on dn square by n minus 1. I'm repeatedly saying for all these things, what is that? Random error analysis, that is Gaussian theory based. I'm writing all these formulae as it is. We need to follow because all the practical random theories are based on these notations only. Okay, right. So this is the formula is to be used when, means concentrate. When n is greater than 20, you have to use this formula in the standard deviation. When n is less than or equal to 20, you need to use this formula. This is what the point here. N greater than 20, that is standard deviation. N less than or equal to 20, that is standard deviation based on the given data. Based on the given data. Right. People are asking, sir, which is correct? Both are correct only. When, suppose I have taken 5 only, 1, 2, 3, 4, 5 only I have taken. Yes or no? Then which must be taken? N less than or equal to 20 is no. This one. That's why this is called as generally what he has given, if n less than or equal to 20, that is taken as finite data system. Finite data system. If n greater than 20 is there, that he has given that infinite data system. Actually, not infinite, only 20 only. What is it? More than 20 means you can take 1, 2, 3, 4, 21 times, 23 times, 24, 25, 26, any number you take. But according to his experimental analysis, more than 20 times if you do the experiment, that will be giving almost related to ideal case. That's why infinite data he has given. So therefore, according to the given data numerically, 5 observations or 10 observations or 25 observations, based on that use this formula. But in the GATE or ESC examination point of view, mostly 10 observations will be given. What is it? Like this, 1, 2, 3, 4. 10 will be, this is a standard theory. Sometimes in the last before year, right, ESC paper, only 5 observations they have given. ESC paper, only 5 observations, like that, 5, 10, etc. But 20, 25 will not be given, no need to, because it is much more lengthy mathematics. That's why they will give maximum of 10 divisions generally. Therefore, use accordingly. Okay, sir, even we do this, what we are getting? After all, standard deviation only. Standard deviation only. We are getting standard deviation only we are getting. So therefore, finally what he is asking, that is what the final point. That is what the final point. And people's doubt is, why n minus 1 in finite data? No, yeah, if n minus 1 is there, that is called as finite data. All I told you, these are the theories, these are the concepts given by the experimental analysis, where we cannot analyze normally with a particular reason. They have given mathematics. That's why kindly, sir, why n minus 1 in the finite data? No, if the n minus 1 is there, that is called as finite data. This is the theory given by the Gauss. Based on the Gauss only, our entire practical world is going on with respect to random error concept. Now, one more question. In order to answer your question, sir, what is epsilon naught? 8.854 into 10 power minus 12 farad per meter. Sir, why? Can you let me know? Why? Actually, question is wrong. This is the standard value. This is the standard procedure for understanding the random error analysis concept. That's what I told you before starting. Only in this conceptual expression, not there only mathematics. You studied in the mathematics subject as the mathematics based. Now I'm converting that into measurement based on the Gaussian theory. Okay. Now finally, very, very important thing is, sir, as the error is randomly changing, concentrate guys, as the error is randomly changing, we cannot get a particular value. Yes or no? We cannot get a particular value. Yes or no? So therefore my question here is, sir, as we are unable to give any particular value, which language you use? Okay, approximately what is the value? Probably what is the value? Probably what is the value? See, that's why as it is randomly changing, we cannot give the exact answer. That's why probably which is suitable. That's why he has given that. Find out the probable error. Find out the probable error, right? If you find out the probable error, that will be taken as which error? Random error. That's why probable error formula experimentally they have given R is equal to 0.6745 times of sigma. This is the final value. Now tell me, finally, in the given data, which is the random error equivalent? Means this is the random error equivalent. That is probable error. Why? As we are unable to give the exact value, we need to standard approximate. Generally, we say probably. Generally, probably we can say. That is the reason why, based on the probable error, they have experimentally taken and give the formula as R equal to 0.6745 times of sigma. Suppose, sir, in this experiment only, you have done all these things. Assume that you have got plus or minus 0.5, for example. Okay, there will be plus or minus common every time. 0.5 you got it. For example, sir, in my example, what is the true value? Approximately I'm giving 2. So therefore, 2 is the true value, plus or minus 0.5 is which value? Probable error, simply random error, something. But my question is, be clear. Don't represent just like this. Don't leave it. Everyone, those who are on the line, be careful. This is the technical point I'm giving. Sir, 2 is the true value obtained in my experiment, in your experiment, like the particular experiment true value. So 0.5 is the value obtained in corresponding procedure in our experiment. Okay. After getting that, no doubt, 2 plus or minus 5 only we write. But don't leave like this. If you are leaving like this, what is the problem? Nothing is there. If you are giving only this, what it implies here? Yesterday's topic, day before yesterday's topic, what is it? Sir, 0.5 is the error with respect to true value. 0.5 error with respect to true value means percentage limiting error. But is it percentage limiting error? No. Percentage limiting error varied with respect to true value, but random error not with respect to value, randomly, zigzagly changing. That's why representation is correct only. But you need to represent this as random error. This as random error compulsory. Otherwise, there is a chance to get confused as, sir, this is percentage limiting error. I can proceed. No, this is not the percentage limiting error. This is the random error. Everyone, representation acceptable, but this error is not with respect to true value. This error is random. That's why keep the random error, probable error, etc., etc. Why I'm mentioning this one means, suppose if you don't mention this, what does it mean? Okay, 2 plus or minus 0.5 means people are writing like this. Sir, 1.52, 2.5 they are writing. Sir, if you are writing 1.5 to 2.5 means below 1.5 not possible, above 1.5 not possible. Means, are you limiting the error or not? Are you limiting the value or not? Yes, you are limiting the value. But random is limited or unbounded. Random error means bounded, unbounded, zigzagly, randomly changing. That's why you cannot give the boundary to the random. If you are giving the boundary means you are expecting something. Expecting something means that is not random. That's why you should not write this type of range at all, because below 1.5, above 2.5, never. In this way, this is not the percentage limiting error. This is what? Random. So therefore, If it is a random, this is not correct. Examples you can see 1.9, 1.8, 3.1, etc. But more than 2.5 should not be there. Less than 1.5 should not be there. But in this, chance is there. That's why we should not write the range at all. That's why from now onwards, see the error in the question. Sir, percentage limiting error is given or random error is given, that you have to consider. GE anyway, right? Random error is there or percentage means percentage limiting error is variable. Random error is also randomly changing means variable only. Both are variable only, but percentage limiting error varies with respect to true value. That too bounded, limited, not less than, not more than. That's what I told you. Maximum uncertainty. Also, I told you in the earlier classes. But random error means variable without any reason, not with the true value, not with full scale value, randomly changing. That's why we cannot give the boundary. We cannot give the boundary. That's why you need to represent the errors properly, right? If you represent like this, nothing wrong, but understand normal limiting error. Okay, you can write the range. Random error, you cannot write the range because we cannot bound the random error. That's why I told you starting when I told you the error which cannot be predicted. The error which cannot be predicted means we cannot bound it. That's why approximate analysis I'm taking. That's why if 0.5 is there, you can write 2 plus or minus 0.5 or 3 plus or minus 0.5, anything, but don't take the range at all. Don't take the range at all. This is the total discussion regarding random error analysis in the experiment. How do you find out all these? Okay, probable error itself is treated as approximately random error value present in the system. This is the total discussion. This is the total discussion given by Gauss. That's why Gaussian statistics, Gaussian mathematical analysis of random error is this. Okay, one more thing, concept not completed. Sir, so far we have taken only one input or multiple inputs. Very important. This entire random error analysis is to be carried out for single input or multiple input. People are getting confused here. Sir, I'm giving X. I'm giving X here. It is given 1.9, 2.5, 3.6, 4, something. See, by giving single value only, this much of headache is there. Suppose if you say, sir, I will give X first. I will give X first. This there. Y then later something. Z. That is not random error analysis. What is that? For a given input, what is a random error? You do that first. Next, after the complete experiment, go for Y. By giving the Y, go for second experiment. Y. Again, take the complete. Again, third experiment. Like that, every time. One input must be taken, or multiple combination means only one input must be taken. That's why what you have to say, probable error of one reading we say, but concentrate. One reading means one given reading, one given true reading, but writing purpose, one reading only we write. Writing purpose, one reading only, but what is that? Probable error of one given input reading. But input given will not be taken, no need to worry. But it implies one reading means one given input reading only. That is what this one. Clear? So this is the total discussion regarding random error analysis. Okay. Now, sir, people are asking one more in this one more thing. Sir, sometimes they may be asking range of error. They may be asking range of error. That's why probable error is over, random error is over. I'm extending the topic. Sir, what is that? In this, we can find one more thing like range of error. Range of error. Sir, what do you mean by range of error? Very simple, very simple. Some experiment will be given like this only. Something will be given, right? Means the values will be like 1.4, 1.5, 1.21, 1.31, like that. Some values will be given. Find out the range of error, they will ask. How to find out? This is also given by same, what is it? Gauss theory only. What is it? First one. First, observe whichever is the maximum value among the events. Suppose 1.2, 1.21, 1.20, 1.19, 1.18, like something randomly changing. Out of all these 5 values, which is maximum, you find out maximum. Okay, and here after finding that maximum, right? Observe, sorry, observe minimum value also, which is minimum. Among the given values, find out that. After finding that, first step is find the mean value. Take the mean value, first step. Second step is maximum value minus mean value we have to take. Second step. Third step is mean value minus minimum you have to take. What is the procedure? First, observe which is maximum minimum, leave it. Next, take the mean value. That mean maximum minus mean value once and mean value minus minimum value once you have to take. Okay. After that, fourth step is range of error. Range of error formula is simply take the average of these two. Maximum minus mean, right? Mean minus minimum, average of these two. That's why sometimes range of error we can say, average range of error, both are one and only same. Don't get confused. Sir, average is not there, it is something else. No, average range of error. In the common language, range of error also we can say. This is the entire procedure for solving. But sir, in the GATE paper for 1 mark model, do we find this much of time for this finding mean, maximum minus mean, mean minus mean, like that? No. That's why I'm giving the shortcut also, direct step. Shortcut. Actually, the formula only shortcut is this, sir. If you observe this properly, these two will be cancelled formula wise. So therefore, what will be there here? Shortcut is directly maximum minus minimum by 2. So this is what the complete shortcut, complete information regarding random error analysis. This is what the complete conceptual topic, as it is not by the theoretical concept. So therefore, we are taking mathematical notation. Clear, guys? So this is what the total random error. I can say all types of errors: gross, systematic, and random errors. Now I'm asking one question. Sir, mathematicians, kindly answer this. Sir, how can you minimize the random error? I'm asking the question, how can you minimize the random error? By which concept you can minimize the random error? How? Mathematicians, you should answer. See, Mano, I'm not saying that elimination. I'm asking that minimization. Very good. Alan Matthew, yes, you're right. Alan Matthew, yes, you're right. You're right. Precision. Who is it? Ratnasagar? Precision is static characteristics. Right? So that's why very simple. Yeah, very simple. I told no, you take 5 readings or etc. That's why take as many as possible readings. If you take as many as possible readings, you will get better mean value. Better mean value means better true value. Better true value means the corresponding error value also better. That means minimize. That is the reason why. How can we minimize the random error is the interview related question. Simply by taking more number of samples, by taking more number of observation. Mathematics people, you know, in order to get better average, right, 2-3 observations are better, 5-10 observations mean more observations are there, more variables are there, then we can say what is it, the corresponding average value will be further better. Average value means our case true value. If you are getting better true value, automatically what is it here? Simply we can minimize the corresponding errors. Yes, many people give the correct answer. Other people, those who give wrong answer, kindly correct it. What is it? By taking as many as possible number of readings, we can get better average, so that better true value, so that minimum error is possible. See, we cannot eliminate it, we can minimize it. Mathematically, conceptually, no. Conceptually, we cannot understand actually. Mathematically only we need to take. That's what the point. This is what the complete discussion regarding random error analysis, complete concept and complete mathematical analysis. Clear, guys? Shirisha B, kindly, sir, please give an example. Again, you're asking the same thing. Random error itself is, I'm shouting like anything. Random error itself is no example. I'm saying kindly, before asking that question, kindly Go through this statement. Clear? The error which cannot be predicted, the error which cannot be expected. Simple logic here. Simple logic. When will we leave this world? When will we leave this world? We don't know. Unexpected. But you're saying that, sir, tell me expiry date, etc., etc. Is it possible here? Definitely no. That is the reason why the error which cannot be predicted. But how can we do means? By the mathematical analysis, we can. By mathematical analysis, we can. Clear? Right. This is what the completely. See, those who are saying that my internet problem is there, for them, recorded video is there, go through that video, no problem at all. Right? 500 members are there. 500 times, if internet problem is there, it is very difficult to repeat each and every topic. That's why recorded videos are provided to you for these purposes only. Yes, Sirisha, I understand your thing, but what is the statement I have told? Not only to you, other people also. Sir, I am asking example of minimization. Example of minimization. Simple logic here, simple mathematics. Take 1.1, 1.2, 1.2. Only three things I have taken, right? Take 1.1, 1.2, 1.3, 1.4, 1.5, 1.6. You only observe this. Take this entire procedure. Take the mean, take the deviations, take the standard deviation, find out the probable error. Definitely, you will get better or minimized error in the more number of errors. Simple mathematics, sir. Better average. When do you get? Here only 3. Here multiple, more than 3. So definitely better will be with respect to more number of variations. You can take that. We are going to take one question. Kindly wait. So this is the complete concept related to random error analysis. Now, power fluctuation happened. Don't worry. Don't worry. I'm bringing that question. Kindly wait. I'm bringing that question. Kindly wait here. One second. I'm writing that question. I'm not finding that. So I'm writing that question. See here. Am I audible now? Actually, just 2 minutes back, power fluctuation happened. That's why it is cut suddenly. Right. Okay. Now, the question is like this here. The following 10 observations. The following 10 observations were recorded when measuring a voltage. When measuring a voltage. Right now, what are those observations I'm giving now? Right. See, 10 observations are there. 41.7, 42, 41.8, 42, 42.1, 41.9, 42.5, 42, 41.9, 41.8. Check it, randomly changing. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 observations are given. Now he is asking find, purely mathematics actually, find mean value, find standard deviation, and probable error of one reading. Probable error of one reading means some input is given, that input notation. I am asking one more thing. What is it? Range of error. Range of error. Kindly let me know. Do we need to solve this, or can you do on your own? Simple mathematics only. Purely mathematics. There is no technical logic at all. Kindly let me know. Do you do from your side, or shall I spend time? For this, I don't think we need to spend here only. Very good, very good, very good. Okay. Right. I will provide the answers. Don't worry. I will provide the answers. Don't worry. Right now, I'm giving the answers for everything. Right. Here, mean value is 41.9. Standard deviation is 0.221. Probable error is 0.143. Range of error is simple. No, here, large. Which is the large in this? I'm doing now itself. Which is the large in this? 41.8. You see that this is the large, 42.5. Which is the smaller one, lower one? 41.7. Yes, 41.7. Take the difference and by 2. I told you, range of error, maximum minus minimum by 2, that you can do. Take this as the homework. From now onwards, I am going to start giving the practice questions every day, topic to topic. Definitely I will give the practice questions. Whether you are doing or not doing, that your interest, but I will give definitely. Right. Bhaskar, he is asking probable error one reading means, sir. Go back and see that. Here, see the heading. Probable error one reading means this one. That's why I generally am saying that. Listen carefully while I'm explaining. Probable error of one reading means this one reading is the input reading. Input reading, I'm repeating, input given value. In this input given value something X. That's why one reading means in this one reading, no, yeah, out of all these things, you need to calculate. That's what the point. Right. Range of error, I'm not giving the answer. You take it. Just now I told you, large minus small by 2, you can get that value. Clear? So this is the total discussion regarding random error analysis. But before concluding this error analysis chapter, I did not say to give the answer now. That is, homework means homework only. Homework means homework only. Clear? Right. 0.14, 0.22. Clear, guys? Right. Now I'm taking other way of explanation to conclude the entire error analysis. Be clear, guys. Now we are going to conclude the, what is it? The chapter called error analysis, and then we'll be entering into the instruments chapter. Be clear. We have done so many questions. Now also I'm doing so many other questions. Sir, what is the point? Concentrate. Everyone. If the, see, I'm Before the time I'm saying, if you are discussing something while I'm explaining this, definitely this topic will not be clear 100%, because this is some tricky model. That's why I'm requesting everyone, don't type after typing the question, and don't say that I missed the topic. Don't request me to repeat the topic. Clear? Listen, I will repeat. If you don't understand, kindly concentrate. If the errors are in, be clear guys, if the errors are in, here, standard deviation means error may be given in standard deviation in the question, that is his wish. Error may be in probable error also. Error may be given represented in random. Actually, random error, probable error, both are same, but the terminology may be given anything. Are very, very important. Very, very good. Sir, random error is variable or constant. Random itself is variable. So means certainty or uncertainty. Uncertainty. Okay. Uncertainty. But concentrate here. Concentrate. 100% you will get confused. Kindly concentrate. I'll clarify that. Sir, uncertainty means variable. Random error is variable. Yes, uncertainty. But can we write maximum uncertainty for this? No. Why? If you are writing maximum uncertainty, you are bounding the error. You are limiting the error. That's why if you are limiting the error, if you are bounding the error, that is called as maximum limit is there. Maximum uncertainty is there. We can say that is percentage limiting error. Yesterday I told you. But sir, in this variability is there, uncertainty is there, but zigzagly, universally, randomly zigzag nature is there. That's why this random error is just called as uncertainty. That's why in the question, maximum uncertainty is given or just uncertainty is given, that you have to concentrate. So that's why, be clear guys, be clear. This is also called as uncertainty. Also called as uncertainty. That's why concentrate. Sir, if I ask the question like, uncertainty comes under which family? Limiting family or random family? Means random family. If I ask the question like, maximum uncertainty comes under which category? Maximum means limited. Limited means bounded. Bounded means, yes, percentage. Nothing but limiting family or percentage limiting family. This is what the terminology. Be clear with the terminology. Okay. And standard deviation, with sigma. Probable error, are, okay. Random error only. Uncertainty generally denoted with W. This is what the question. Okay, right. Means Gaussian theory is not yet over here. Gaussian concept we have taken. Now we are going to take numericals also. What is that? Kindly concentrate. Definitely confusion will be there. Generally, from any batch, from every batch, every batch, I'm getting more doubts on this topic because the topic is like that. But you people are normally asking many doubts. That's why I may be getting more and more doubts in this topic. That's why I'm requesting everyone to concentrate more and more. If you concentrate, doubt will not be there 100%. Kindly concentrate. Sir, here, suppose I1 is equal to 100 plus or minus 4 amperes is given. Okay, right. Sir, I2 is equal to 50 plus or minus 3 amperes is given. I1 100 plus or minus 4, I2 50 plus or minus 3 is given. Okay. He is asking I total, that is I1 plus I2 is dash. I1 plus I2 is dash. This is what the question. Clear guys? This is what the question. But be clear, until I complete, kindly, step by step, each and every step playing the crucial role. So concentrate. Sir, undoubtedly, sir, I1 plus I2. Okay, forget about this heading for one moment. Forget about this heading. Sir, I1 plus I2. Same thing we have done in yesterday's class, day before yesterday's class or not? Yes, what is it? I1 plus I2, 100 plus 50, 150. 4 plus 3, 7. Why? Why means nothing is mentioned. Means error with respect to true value, limiting family. Error with respect to true value, limiting family. So directly added. But I'm mentioning that, sir, these errors are not limiting form, these errors are given in standard deviation. Means the moment you observe that the errors are given in standard deviation means you need to understand that, okay, errors are given in standard deviation means, consider here, the standard deviation is coming under random family. Coming under random family means, okay, random analysis we have to use means Gaussian analysis we have to use. Okay, now I'm taking the procedure. In this, I'm explaining the procedure. I'm going to explain shortcut also, whichever is you are feeling, whichever is comfort to you, you can follow. Okay, right. First, I'm taking the procedure. This procedure is given by whom here? Gaussian. What is the procedure? See, in the random family, because standard deviation is random family, probable error random family, random that random family, uncertainty also other name of random error. Okay, any name may be given in the question. Okay, so what procedure says, what you require, that is I total is equal to I1 plus I2. That's what you require. Okay, now take the partial differentiation of whatever the required parameter with the available parameters, dou I total by dou I1, partial differentiation, dou I2 by dou I1, like that you have to take. Suppose immediately people are asking, sir, I3 is there, so what? Take dou I3 by dou I2, sorry, one second, dou I total by dou I total by dou I2, dou I3, dou I4, like that. One second. So this is dou I total by dou I2, like that. Dou I total by dou I3, dou I total by dou I4. How many are there? Take those many. I think everyone knows partial differentiation, right? So this differentiation with respect to I1, but partially means 1 plus this will become constant partial differentiation 0. So what is the answer? 1. Okay. Dou I total, this one, differentiating with I2 but partially, 0 plus 1, 1. I hope everyone knows this mathematics, partial differentiation. Okay, right. After that, sir, simply I total value will be, sir, 150 always to be added. Why? True values, there is no change. You're adding no here. Yes, 100 plus 50, 150, there is no problem. That's why I told you there is no problem with the true value. When you add, when you subtract, when you multiply, when you divide, take according to the operation. 100 plus 50, take 150. Okay, but problem is we have to get the error. Which error? Standard is given for I1 plus I1 and I2 means standard should be represented, means standard deviation only we need to represent for resultant value also. Clear? Right. Now, so I total no problem, true value no problem, but problem is with error. Which error? Standard deviation of I total. That's why standard deviation of I total formula given by Gaussian theory is root of concentrate. First differentiation, dou I total by dou I1 whole square into which with which parameter differentiating I1. So therefore sigma I1 whole square. So why are you writing sigma? Means he has given sigma only. Okay, plus second differentiation, dou I total by dou I2 whole square into second error no here. So second current sigma I2 square. Now concentrate, sir. What is dou I total by dou I1? 1. So simply 1 square into sigma of I1. Sigma of I1, 4 square plus dou I total by dou I2 square, 1 only, 1 square. Sigma I2, this is sigma I2, right? So therefore 3 square, right? Now you are getting 5. Anyway, error will be there, no? Plus or minus. What is that current now? Yes. Now you can write 5 so many amperes. But be clear. Sir, if I don't represent this, means if I represent this as the percentage limiting family, what is the answer here? 100 plus 50, 150 plus or minus a direct addition. Why? Addition is there, value form of error is there. Then last class topic. What is that? Limiting family topic. 100 plus 50, 150 plus or minus. That is normal process. But this is random family process. Therefore, this is the entire procedure. I'm repeating what did we do? Differentiate the total required parameter with the variable 1 with the variable 2. Differentiate. After that, root of, take the first differentiation square into first error square. Standard given, standard deviation. Second differentiation square, second error square. Value, that value you have to substitute here. Okay, but I'll come back to this again. Don't worry. Now, shortcut. Right. I will give the shortcut later. Yes, come on here. Will they mention? Very good. Amit Kumar, will they mention? Because if you need to answer means I need to ask the question. So therefore, they will mention. They will mention to confuse you. Definitely, they will mention. That too, they have to mention. Otherwise, we cannot give which is the error guarantee. That's why simply they will mention. They have to mention. That is the question. That only I mention. Don't think like I mention according to my interest. No, that is a pattern. That is a pattern. Means if I'm expecting solution from you, definitely I need to ask the question. No, yes, this is the question. Clear, guys? Okay. Now shortcut I'll give you later. Now I'm taking the second question. In the random analysis, second question. What is that? Sir, in this we have taken addition operation we have taken. Immediately people are asking, sir, what about multiplication? Explain. I will explain. Multiplication I'm taking. Right? Multiplication I'm taking. Right? Kindly concentrate here. Sir, when the values are given like this, V is equal to 100 plus or minus 4%. I is equal to 50 plus or minus 3%. So many volts, so many amperes. Before my question, people are asking that, sir, if the errors are in percentage, kindly wait, already told you, kindly wait. Okay, 4% and 3%. Okay. Now, suppose if I'm asking power is equal to V into I is dash. I have not mentioned anything. Everyone should answer this fastly. What is that? 100 into 50, 5,000. 4 plus 3, 7%. That is normal family, limiting family. But in my question, this is either standard or probable or random or anything may be given. Idea purpose, I'm giving this as probable error. What is it? This is not the limiting family error. This is the probable error family. This is the probable error family. I'm repeatedly saying this is the probable error means random family. But don't think like, sir, here only sigma should be there. No, R may be given. If R is given, you write R here, you write R here. That's it. But for question point of view, one notation I'm taking. That's it. One question with this one question with this one question like that. I'm taking different combination of the questions. Clear? Right. Concentrate. Sir, in this, find out the power formula. Okay. Right. Now, procedure. I'm taking the procedure. Right. Sir, what is the procedure? Be clear. This is a random error analysis procedure. Out of the shortcut, within 30 seconds only you can do it. Within maximum 30 to 40 or less than 1 minute you can answer. But without procedure, even if you're taking shortcut, something will be missing. So that's why I'm standing on the concept first. Procedure. So therefore, so what is the procedure here? See, in the procedure point of view, either addition or subtraction or multiplication or division, anything is a value form of errors only we need to have. That's why what you have to do, sir, V is equal to 100 plus or minus 4%. 4% of 100 is 100 plus or minus 4 I'm taking. Means percentage is converted into value form. But I'm not writing 96 to 104. I'm not writing. Can we write like this here? Just now I told you. Can we write 96 to 104? No. If you're writing like this, this means which one? Limiting family. But it is not limiting family. Leave it. Next, I is equal to 50 plus or minus 3%. Okay, 3% of 50 is 1.5. Again, I'm saying don't write 48.5 to 51.5. If you write like that, that will become which error? That will become which error? Bounded error, limiting family. But this is random family. That's why range should not be written. Range we don't know, that is randomly zigzagly change. One thing. Second thing, sir, P is equal to V into I. Okay, sir, dou P by dou V. What is the value? Dou P by dou V is equal to I. I think everyone knows partial differentiation. After that, dou P by dou I is equal to V. Clear, sir? What is I true value? What is I true value? That is, I true value is 50. So simply this value is 50. Okay. What is V true value? 100. That you have to substitute. I'm coming again. After observing the differentiation, if any variable is coming, that true value you try. But in the earlier question, we have got 1. No need to substitute, directly 1 only. Here, something else is there. Okay, right. After that, same procedure here. What is that? Sir, power is equal to 100 into 50 is common because you're multiplying. So therefore, 5,000 into, so 5,000 plus or minus. I need to have some error, so many watts, but this error must be in which one? Probable error form only, because he has given probable error form. We need to represent in probable error form only. That's why I'm taking probable error of power. R means probable error, power. Resultant parameter, what we require? Root of what I told you, first differentiation, dou P by dou V whole square into probable error of voltage whole square. Clear? After that, differentiation, second differentiation square, probable error of current square. Okay, same procedure. Whatever we have done, same thing. But here, current is given. Here, voltage and current combination is given. Different combination. Okay, right. Here, sir, substitute dou P by dou V. First, let me take the root. Dou P by dou V is 50 square into RV. Here, you need to take care. RV means probable error of voltage. What I told you, not percentage. In the procedure, value form. So therefore, you have to take 4 value form square plus dou P by dou I, 100 square. And RI means probable error of current. Which one? 1.3 you have to take. Right? If you simplify this, you will get 250 watts. You will get 250 watts. So what is the probable error in the power? 250 watts. Okay. Therefore, P is equal to 5,000. Therefore, P is equal to 5,000 plus or minus 250 watts. Yes or no? And don't forget, sir, this is which error? Probable error only in value form. In the options, it may be there, or in the options, he may be expecting percentage form also. Sir, 250 is dash percent of 5,000. 5%. So simply 5%. Both are correct only. One is in the value form, one is in the percentage, because percentage given is percentage form. This is the total step-by-step procedure in detail, elaboratedly I have explained. But sir, I am forgetting the steps. Definitely that is possible. That's why after the class, today only or tomorrow morning only, practice these questions, especially because what are the questions so far we have taken, that is normal calculations only. But here, logical based is it. That's why practice these questions compulsory. Practice these questions compulsory. And immediately, without completing this, people are asking, sir, what about division? Don't be that much over enthusiasm. Right? What I told you, multiplication I told you. Can't you do division? Same concept. Addition I have done. Can't you do subtraction? Very simple. Yes or no? Now, I'm taking the third question. In that, your topic is coming. Kindly wait. That's why I'm requesting wait. That is, which one here? Simply. In this, multiplication will be there. Division also will be there. In this, multiplication will be there. Division also will be there. So that I'm going to take now. But be clear. One second. One second. Here, sir. I'll be taking the shortcut for these two first. After that, I'll be explaining all varieties of questions. All varieties of questions. Okay. Right. Here, people are asking some questions. Sir, here, if the percentages are given, percentages must be converted into value form. Value form of errors only to be used in the procedure concept. I told you already, I'm repeating. What is it? In the question, if percentages are given, if percentages are given, convert them into value form, substitute the value form of error in the procedure. I'm repeating this, okay? But immediately, people are asking, sir, in the earlier question, we have not converted, no? In the question itself, they have given value form. Value form converted into value form, meaningless. So that's why in the first question, value forms are given directly. Therefore, I have taken value form of errors directly. But in the second case, percentages are given. If I'm following the procedure, value form of errors must be substituted in the procedure-based formula. That's what I'm repeating. Clear? Right. Bhavani, I think it is clear. In the earlier question, it is given as value form only. Value form convert into value form. Meaning is right, not required. And yes, correct. Got it. Very good. Chandan Chetri, right? And I told you just now, what is it? In the procedure point of view, value form must be substituted. This is the standard procedure in the random error analysis given by Gaussian. Okay, Dwarakesh, clear, right? Sir, Muhammad Mudassar Nazar, formula divided by n. Where? Why to divide? Why to divide by n? Be clear. When you have to divide means when the observations are given, when the mean value is taken, deviations are taken, and standard deviation is to be determined. But in this question, standard deviation only given directly. Means in the previous question I gave no, this one. This value is given directly. Where is the question of divided by n here? No way. This is the procedure when observations are given 10, 15, 20, 30, etc. Then mean value, deviation value, standard deviation value, probable error value, like that. But in this, after calculating the standard deviation, they have given standard deviation of current is this, standard deviation of second current is this, like that. After that, for one experiment, taking so many observations, calculating the standard deviation, calculating the probable value for voltage, for current, then they have given corresponding value. There is no question of divided by n at all. So this is the total discussion related to numerical questions, procedure only. But don't worry, within 35 to 40 seconds, how can you answer? I'm going to be the shortcut later after the break. Clear? I take the break and come back for 15 minutes. Leisurely take the break and come back. Yes, come back everyone. Right. Right. See, people are asking that, sir, you have taken 3% means 3, no, you have taken 1.5. Come on, yeah. 3% of 50. 3% of 50. I'm repeating, 3% of 50 is 1.5. Kindly come out of the impression like 3% means 3 by 100, 3 only, not like that here. 3% of which parameter? 50. In 50, what is 3% here? 1.5 only. That only I have taken. Clear? Chandan Chatri, right? Next. So can we differentiate SD and probable error? What do you mean by this? Can we differentiate SD and probable error? What do you mean by that? Differentiation of parameter, only true value, not the probable error, standard deviation. We should not. Only in this procedure what I have done, that only to be followed. Okay, right. Come back here. So shortcut. Very important step for calculation in the examination point of view. Here, sir, I'm talking about I1 plus I2 addition. I1 plus I2 addition, right? Now, yesterday and day before yesterday, one shortcut I gave you. For multiplication and divisions, which form? Percentage form. For addition and subtraction, which form? Value form is required, I told you. Yes or no? So therefore, concentrate. Sir, addition is there. Shortcut, I'm talking shortcut. Okay? Addition is there. Value form of errors are there. Addition is there. Value form of error. Therefore, directly shortcut is, sir, I total, there is no doubt 150 common because I total 100 plus 50, that is common. Now, what is a shortcut? You know, standard deviation of I total, shortcut here is concentrate. Sir, what is the formula? I total is equal to I1 plus I2. I total equal to I1 plus I2. Okay, right, sir. Here, sir, I total equal to I1 plus I2. Shortcut I'm explaining. Without having this entire procedure, you can get the answer directly. Anyway, true value will be there. This value directly you are getting. What is it? Let me take. Sir, first, I1 is one variable, right? What is the I1 to the power in the question? I1 to the power 1 only. 1 into. What is the I1 error given? I1 error is given as 4 square plus I2 to the power 1 into. What is the I2 error? I2 error is, error means standard only, but error. What is that? 3. 3 whole square. So directly plus or minus 5 amperes. Here plus or minus 5 amperes. This is which one? Standard deviation. Direct shortcut. I'm repeating. Don't worry. Don't worry. Next question. Next question. Next question. Also, I'll do the thing. No need to worry. Until you get clarity, I'll keep on taking the question. Don't worry. Here, sir, I1 to the power 1 into I1 error. Follow this 4 square plus I2 to the power 1 into I2 error is 3. So 3 square. So plus or minus 5 amperes. Plus or minus 5 amperes. Clear? Right. Now, coming to this one. Sir, P equal to V into I. P is equal to V into I. What is it? Multiplication. What is the shortcut I told you in the day before yesterday class? What is it? Okay, multiplication or division. Percentage form we require. Yes, percentage is there. We can apply the shortcut directly. But in the, what is it? Random error analysis, Gaussian procedure, values must be used. But shortcut is shortcut only. That's why multiplication, what is shortcut here? Percentage form must be used. So therefore, concentrate. Sir, power is equal to 100 into 5, 5000 common. I require which one? Probable error form. I require probable error form. Clear? Right, sir. Probable error of power is equal to shortcut. Same thing, root of. So what is the formula? P is equal to V into I. P is equal to V into I. Sir, what is the V power? 1 into. What is the V? Percentage error, because shortcut multiplication. All I told you in the last class. What is it? Multiplication in the shortcut percentage form is right. Percentage 4. So therefore, write 4. Keep the percentage outside shortcut. Square plus. Sir, I to the power 1. I to the power 1 into. What is the I percentage error? I percentage error 3. 3 whole square. Sir, directly 5%. Directly answer you're getting final answer in one step only. Here we have got value form, differentiation, value form into percentage form. But shortcut directly 5%. I'm coming again. Sir, what is the voltage to the power? 1. What is the current to the power? 1. What is the voltage percentage error? 4 square. 3 square. So 4 square, 3 square, 5 square, root cancel 5. So direct answer. If you follow this, automatically maximum 1 minute of time you can answer. Blindly you can answer in maximum of 1 minute only. Clear? Okay. Still, if any doubt is there, generally this is not so easy until you practice it again. That's why while I'm explaining concept and everything is clear or not, yes, then after the class kindly I'm requesting everyone to practice once, then the things will be clear. Now I'm taking third question. This is the previous gate question of instrumentation people, but common for electrical and everyone. ESC also same thing. Sir, R is equal to 4 rho L by pi d square is there. 4 rho L by pi d square is there. Okay. To lengthen the question, to give the lengthy question, rho is resistivity in ohm meter, L is length in ohm meter, D is L is length in meter, D is diameter meter. That everyone knows that. Right? No need, right? After that, rho, L, D are having the error of plus or minus 1% each. Plus or minus 1% each. What is the value? All these are having plus or minus 1% each error. Okay. Now what he's asking, gate paper question is given, but I'm adding some other question. Means I'm giving 2 questions. Means I'm adding one more question to the gate question. I'm giving that combination question to get more clarity. Find the error in. Find the error in the value of resistance. Value of resistance when the given errors are in the given errors are in, actually in the examination only one question, but I'm giving, when the given errors are in, first one, relative form, second one, random form, relative form and random form. So what is relative? I'll tell you, relative means relative static error family. Therefore, first question is percentage limiting. Second question is Gaussian theory, random. Actually, this is not given in the question. Only this is the previous gate question, but clarity purpose, earlier topic and this topic, I'm combining to give the complete conclusion. Okay, what is that? When the given errors are in relative form, so when the given errors are in relative form, automatically error in the resistance should be in relative form, that we have to calculate. When the given errors are in random form, result must be in random form only. Okay, right. First one, I'm solving here. First one, what is it? Percentage limiting error in R. Sir, why? Limiting form. Limiting form is there, so therefore automatically we can say this only. What is it? Relative form means limiting only. Okay, right, sir. Percent limiting in R. Be clear, this is day before yesterday, and just like in order to understand that, I'm saying that day before yesterday topic, so that you can understand the topic. What is that? Sir, error in 4 not there, constant value. Error in pi not there. Sir, error in row, 1%. So therefore plus or minus 1%. Error in L plus or minus 1%. Error in D plus or minus 1% square. But don't forget the procedure. Error square is there means multiplied, I told you. So therefore plus or minus 1% plus or minus 1% plus or minus 2%, because 2 into 1. So what is the value? Errors multiplied, errors division. What is it here? Plus or minus, all must be added 4%. This is what the limiting family day before yesterday's topic. Day before yesterday's topic is this. I hope there is no doubt in this, because we have done so many questions on this. Now, coming to the second part. Coming to the second part. What is that? Random error. Random error in R. Random error in R. Root of. Random error in R. Root of. Concentrate here. So 4 and pi. Constant, will leave it. What is the row to the power? Shortcut I'm using. What is the row to the power? 1. Kindly, while I'm asking the question from your side, you can answer. No need to type, but you can answer. What is it? Row to the power means immediately 1. Okay, I've written 1 into. What is a row error? What is a row error? 1%. Yes. 1. Immediately keep the percent outside, all I told you. Square plus. Sir, what is a L to the power? 1. In the question, 1. What is the L error? 1 only. So therefore, 1, but already kept the percentage outside. No problem. Square plus. Sir, what is the D to the power? 2. Therefore, 2 into. What is a D error? 1 only. So therefore, 1 whole square. Here people's doubt is, so D is in the D square, the denominator, we should write minus 2. Even though you write minus 2 plus 2 square will be there, no problem. So therefore, 1 plus 1 plus 4. What's the answer here? Root 6%. Root 6%. This is what the gate earlier question, but this is added to understand when the error is in the normal form, relative form or limiting form. When the error is in random form, this is the procedure. What is? One is 4%, one is root 6%. Clear? Now I'm asking the question, random error analysis, numerical questions, what I explained is clear or not? Can you respond? Come on. Right. I'm not asking about something else. What I have taught, that only I'm asking. All I told you, after going, sorry, you're at home only, no? Right. After the session, at least today or tomorrow, at least, kindly, you need to practice this compulsory. You need to practice this compulsory to get more perfection. Right. Sir, which type of questions asked in the exam on random error? What are the questions I'm taking? Yes, all these will be asked definitely. And P. Srihari. Sir, how we consider P equal to I equal to 1? What is it? P equal to I equal to 1? Yeah. Practice questions. Only the thing is, you need to have the patience. That is, I will be giving more and more and more numerical questions compulsory. Here, this is the question. And you don't ask it, how do we know? That is a question. Yeah, this is the question. Okay, if you are having doubt, I'll keeping Q. It is a question. So how do you know rho LD1? And that is a question data. Yeah, that is the question data. Clear? Right. Now many people's general doubts are dynamic error and random error. No comparison, both are separate. Right. Srihari, this is the question. This is the question. I'm repeating, this is the question he has given in the examination. He has given in the examination. Rho to the power 1, nothing is there. We can, if you see that, we can understand. L to the power 1, D to the power 2, we know. Rho LD errors are given as 1% each. This is the entire thing. Is the question. Is the question. Okay. Now, one student asked one good question. Right. Bhukia Bharat. 1 square is 1 only, na? 1 only I have taken, yeah. 1 into 1 square, 1. 1 into 1 square, 1. 2 into, what is it? 1 square is 4. What is that value? Root 6. Is anything wrong in the value? Is any wrong thing in the value? Bharat? Right. Yeah, you can get plus or minus, no problem. But still people are asking, sir, in the above step, 1 into 1 equal to 1 means I cannot do anything at this stage. All I told you, errors are in multiplication form. What you have to add, I told many of the times. Bhukia Bharat, I told you already day before yesterday. This is only to revise the topic I told you. Revise the topic I told you. Clear, guys? Multiplication. When the multiplication is there in the error, did you remember day before yesterday? W equal to xy by z we have taken. X error is plus or minus 0.5. Y error is 5%. Z error is plus or minus 1.5%. What we have done? Did we do like this? 5 into 0.5, 2.5, 2.5 by 1.5. Did we do like that? Yeah, no. Errors multiplied, percentage errors multiplied, addition. We have taken 7%. That's why I'm saying that kindly follow the notes after the class. See, few people are asking me that, sir, file is not uploaded. When will it uploaded? In that way, they're asking. Other people, file is already uploaded, but not preparing. Arre, come on here. Come on. Do the hard work. Kindly practice them. Right? Okay. Now, I'm coming to that. Sir, people are asking this. Yes, I'll be saying that. Sir, in this question, random error, do by the procedure, sir. Before asking the question, I'm saying every time, think about your question. Think about your question. If you are asking like that, I don't be losing anything. But before you are asking one question, think once. People are asking, sir, random form, you use the shortcut. Why don't you use the procedure? In your question itself, answer is there. Okay. R is equal to 4 rho L by pi d square. Okay, procedure. Dou R by dou rho. What will be there? Dou R by dou rho means 4 L by pi d square. So what is L value given in the question? Has he given any L true value? Not given. D true value? Not. That's why in this question, procedure we cannot use. That's why I have given the shortcut directly that I'm going to explain. Wait for 1 minute. Kindly have the patience. That's why in this procedure is not suitable. Means what I'm saying, in this question, suppose if I'm erasing these two, for example, can you go by this procedure? No. Why? Dou P by dou V. I. What is I value? Not given. Yes or no? That's why the procedure will be when true value along with the error value is given. Procedure is possible anyway. Shortcut is also possible. But in this gate question, true value of rho, true value of L, true value of D is not given. Therefore, we cannot go by the procedure. That's why I've taken simply shortcut. That's why before asking the question, if you try, you will understand. Okay, R equal to 4 rho L by pi d square. 4 rho L by pi d square. So immediately, dou resistance by dou rho L is D is not. That's why in this shortcut, that is what I told you. Clear? Any confusion? You can ask it out. No, not Malesh. No. How can you think those will be cancelled? No. Okay, right. I'm giving the question. This is the second question homework. Right, Pratik, Pramod, yes sir, same doubt. That's why I will explain everything. Don't worry. Here, V is equal to 100 plus or minus 4% volts. I is equal to 50 plus or minus 3% amperes. What we have taken? We have taken in the which form? Power form we have taken. No, constant term will not affect because constant term will be having zero error. Why? Error is not given, zero error. So that's why you can substitute 0, 0 something. So constant value does not affect. Right? Very good. So in this, I'm asking you to find out R is equal to V by I. R is equal to V by I. But everyone should do in the homework, but not only shortcut. Procedure based you have to do, because if you do the procedure, you are getting small doubt, and shortcut based both you have to do. Many of the batches people ask the reverse question like, sir, shortcut is okay, procedure I'm getting confused, procedure no, I'm not getting. That's why I told you mathematics plays the role. Differentiation, partial differentiation, that you have to concentrate. Partial differentiation, that you have to concentrate. Clear? Right. Now, take this as a homework, but people are still asking the question. Sir, question 3, first bit, denominator part 1, square is 1 only. No, sir, how it is 2? I cannot do this, Bukya Bharat, if you ask this again and again. I told you, go back to the earlier. Bukya Bharat, kindly, you only respond. Did you attend my earlier class? Did you attend my earlier class, Bukya Bharat? Day before yesterday and yesterday, like 3 days class. Did you attend? Right? If you attended, you should not ask this question, because I told almost 10-20 times I told this procedure. When I was explaining P equal to I square R, P equal to I square R, the student is asking that 1 square means 1 only. No, error, yeah, error. I told you 2 into 1, error will be coming over here. I told you clearly in the last class. Kindly go through that. Right. See, only one thing I would like to speak something. See, people are saying that my topic is clear. Okay, I'm very happy, but that is not sufficient. That is not at all sufficient. I'm requesting everyone, right? People are saying that the topic is clear, we're understanding. Okay, but unless you have the practice, if you don't have the practice, how much I explain, it is waste only. I'm requesting everyone, after the class, you should prepare compulsory. Means what I told you already. The moment you're coming to the next day class, before coming to that class, previous sections, everything must be simplified, solved, and revised by you compulsory. If that is not the case, definitely no use of taking, no use of shouting like this, no use of taking these many examples, and no use of repeating these many doubts and continuously, no use. So that's why if you're understanding, I'm very happy, no problem. But my question is, see, if I explain, you won't get the gate rank. If I explain, you won't get the gate rank. When you get the gate rank here, when you prepare from your side. That's why after the class, everyone should do one thing. First concentrate here. I'm giving the preparation tick here. That's to avoid the mood, to change the mood. Sir, after the class, whatever the notes is given to you or returning, or we are uploading now, by seeing that every topic you need to revise first. Don't overlook like, I understood in the class, I will skip it. No, once again you see that, at least practice, otherwise at least go through that. Okay, this question is like this, you might have understood very clearly, happy, but while you're practicing at least once, okay, in this way you have done, in that way you have to revise compulsory. Then what are the questions are available with you, practice those questions, then only you will get the gate rank, then only you will get the gate rank. Because whatever the thing I explained, you will not get the gate rank, right? Whatever you understood in the classroom, that is not sufficient. You need to practice again and again and again. That's why from June 1st, you started, no, from June 1st to Jan 31st next year, rigorous preparation, continuous preparation should be there. Okay, I listen the class, I know, don't overlook. I have seen so many students, those who overlook like that, they disqualified. Last year also, one of the students generally in the contact with me, whenever I asked them, sir, I understand, sir, I understood, sir, I understood, over gate exam, not qualified, means after the class, practice was not there. In the classroom, everything will be looking like clear only, because I am writing all the steps. If I am writing all the steps, if you are observing while I'm writing, you can understand that, okay, one is there, etc. But when you see this question, when you take white paper and practice it, then the problem will be there. Here, one should be taken, or two should be taken, or plus should be taken, or minus. Like that, after the class, you need to practice compulsory. That's why so many people told that, sir, after the class, I did not prepare. After the class, I did not practice. And while the classes are going on, I skipped the classes by thinking that I will listen the classes later in the recorded videos, but I couldn't do. I got disqualified in the gate. When you said all those things, I did not care about your words, but now I'm facing the problem. So many students said in the last year. That is, I'm requesting everyone. I'm requesting. I don't want to get the call from you by stating the same statement again. I'm requesting everyone. That's why prepare well. That's why after the class, definitely you need to practice. Until and unless you practice, you will not get. Openly, I want to say openly one thing. See, our explanation, class explanation, will be useful for you 30% in the gate, 30% marks only in the gate. If you don't prepare, if you don't write anything, you will get like this. But along with our explanation, if you practice more and more and more and more, that will be increasing from 30 to 40, 50, 60, 70, 80. That is the thing. That's why faculty will be helping to only to give the subject and practicing the question. If I solve more questions, I will get improvement. But when do you get improvement? Are you getting or not? If I do questions continuously, improvement will be from my side, but that is not enough. Improvement from your side. That's why I'm requesting you, prepare well. If the faculty says like this, you may not be understand. Come on, every faculty says like this only. No. After losing the gate rank, you will understand. After losing the gate rank, you will understand. That's why to lose the things, why to get realized, why to felt bad, etc. No, simply prepare well. Now only you prepare well. Clear? Very good. Dinesh, very good. Yes. So from today we'll practice, sir. Very nice. Right. Right. See, I don't understand. Why don't you have the patience? Question is not completed here. Before completing the question, some people ask the doubts. I went to there. I went to there. People are asking, sir, you have not completed the question. I know I have not completed the question. I have not completed the question. I know. Kindly concentrate. Kindly concentrate. Have the patience. Yeah? Have the patience. Right? And now I'm giving this error is random error. No satisfied, I think. Now I give this answer as random error. Okay. Right. People are saying that, sir, I joined in the June 1st batch. Where should I get the practice questions? In the OTS platform, in the content platform, wherever you are watching the uploaded videos, wherever you are getting the written notes PDF, there only CRO or CRP, classroom practice or classroom object question. One file is there. We made complete questions, one file. You practice those. You practice those. Okay, see, you are very smart. You are very smart. Concentrate, sir. People are giving the answer. I don't want. I don't want the answer because you can give the answer 100 by 52 root of 4 square plus 3 square 2 plus or minus 5. Everyone say that. But what I told, this is by shortcut. Okay, but I already told you to verify by the procedure, by the shortcut. You should get the same answer that you practice. You give the answer. 2 plus or minus 5% is answer. I'm giving that 2 plus or minus 5% is answer because simple logic. Shortcut I'm doing. In the shortcut, root of voltage power 1. Error is 4 square percentage. Current power 1. Current error 3 square. You will get the 5%. That is clear. 100 by 52. That is not I'm asking here. I'm asking you to practice. If I want to have the answer, answer is there directly, but I'm not expecting the just answer from you. I'm expecting the procedure based process. What is it? You must be perfect. You must be perfection in the corresponding procedure based. Yes, that's what. Tulasi, Tulasi, sir, in the procedure we are facing the problem. Yes, I want you to face the problem so that you can understand more. That's why I'm giving 1 day of time. You practice, you practice. That's intention I give this question. Right. Right. See how to send the screenshots of questions. Don't worry. Next class, I will ask the questions. No need to worry. Right. Slowly, day by Jayasri, I'll tell you everything. But everything, if I say only in 1 day, you will get bored. You will be forgetting. Every day, one thing, I'll tell you. And right. Okay, people are asking, so do you have any PDF of textbook? Yes, I have AK Sahane textbook PDF with me. I will send you. So many people message me. I'll send to that one person. You can circulate in your along your whatever the group you are having. Right. So difference between standard deviation probable error. Probable error is 0.6745 times of sigma. This is standard deviation. This is probable. Means probable error is 0.6745 times of sigma. Okay. This is the total discussion regarding complete error analysis chapter. Complete error analysis chapter is this one. Clear? Right. See, for everything, immediately question. Sir, practice question. If you have doubt, if you understood the topic, you should not have any doubt. And second one, tomorrow I'm here. I will be here. I will be here. Next day, you can ask that before starting the question. So before starting the class, I will solve the homework question. Then only I'll go to the topic. Aishwarya, don't worry. Don't worry. I'm not leaving this world today only. Tomorrow also I'll be there. So I will be clarifying doubts. No need to worry. Ashish Kumar, very good. After long back, I got the message from you. Very good, very good. Definitely. Vaishnavi, definitely. I'm here not only to explain only measurement, blah, 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 blah. No, you need to get everything which are required to the GATE exam. In that way, I'll be definitely talking to you, no need to worry. Okay, right. Now, before closing this entire chapter, a special case topic. Vaishnavi, welcome. Special case topic. Likita, in class we are doing problems well, but practicing some definitely. That's what if you practice more and more and more and more, automatically that lengthy time, more time becomes less time only. You need to practice more. See, only 3 days over here, only 3 days over. Definitely you need to practice more and more. Okay. Ashwani, tomorrow holiday. Every Saturday there is a break to the class, but in the Sunday 2 to 8:30. In the Sunday 2 to 8:30 class will be there, right? Saturday break will be there. Every Saturday break because continuous session. No, you need to have some time for practice. That's why every Saturday break. I know sing okay, right? Kindly don't type anything. Right. People are asking, come on here, you are, sir, one topic is remaining, uncertainty topic. Okay. In the homework question, in the place of this, you keep this as uncertainty. Over. That only, right? Only name is different. Procedure is same. Procedure is same. Yes, partial differentiation, you face the problem means you are not perfect in the mathematics. That's why I gave this as the homework question. Tomorrow, complete day time is there. Go to the mathematics and follow the partial differentiation. I will solve in my class. Definitely, don't worry. Let me explain this. Sir, special case. This is a special case. I'm repeatedly saying special case. Parallel connection. Again, one message. Right. Yeah, Shirisha, that only I'm doing. Very good. Here, parallel connection of resistors. Parallel connection of resistors is a special case. But be clear, parallel connection of resistors, parallel connection of inductors, series connection of capacitors. Everyone knows that R1, R2 by R1 plus R2, L1, L2 by L1 plus L2, C1, C2 by C1 plus C2. If the parameters are in this format, that is called as special case. That is called as special case. So I'm explaining here also. Procedure will give you, shortcut also I'll give you. Be clear, sir. Question, sir. R1 is equal to 100 plus or minus 2% ohms only. R2 is equal to 50 plus or minus 1%. 50 plus or minus 1% ohms. Both are connected in parallel. Both are connected in parallel. Then find out R parallel is equal to R total is equal to, everyone knows the formula, R1 R2 by R1 plus R2 is dash. And I have not mentioned any name. I have not mentioned any name means limiting family only. Limiting family only. Clear? Percent limiting only. But if the random is given, that procedure is very lengthy. That will be there in the generally ESC conventional model, not for GATE, not for ESC objective. Don't worry. That's why percentage limiting is, that's I'm not mentioning. If I don't mention, error with respect to true value means percentage limiting. That is for sure. Okay, right. Now I'm taking the solution. First, I'll be taking procedure. First, I'll be taking procedure. Then I'll go for the shortcut. Directly you can answer. In that, all different doubts will be clarified. See, before asking this, I would like to give one question. Sir, here, in your network theory, V1 into V2 by V1 plus V2, something is there like this. V1 into V2 by V1 plus something is there. V1 equal to 5 at an angle 30. V2 equal to 6 at an angle 20 is there, for example. Otherwise, sir, V2 is how much? 3 plus J4 is there. What you have to do here? Simply V1, 5 at an angle 30. 3 plus J4 by 5 at an angle 30 plus 3 plus J4. Sir, multiplication is there in the numerator. What you require? What you require? Polar form. So therefore, 5 at an angle 30. Convert this into some polar form. Okay. Sir, denominator addition is there means convert this into A plus or minus JB like that plus 3 plus J4. Okay. Sir, multiplication. You do that. What you will be getting? Magnitude, angle. Here, real part, imaginary part. What will be there? X plus J, Y will be there. Sir, again, division is there. What you have to do? Product, corresponding angle. Here, you have to convert this into any. That's why in the network theory, polar to rectangle, rectangle to polar, polar. So many times we do know. Same thing in our measurement also. Percentage to value, value to percentage, percentage to value, value to percentage. So many times you have to do. You have to do. That's it. Okay. Next, second point. Here, concentrate. I told you special case, don't give the answer. I told you already, this is a special case. Don't give the answer right now. Okay, sir. What is the procedure? You know, R1 is equal to 100 plus or minus 2%. So convert this into value form. 100 plus or minus 2% of 100 is 2. Sir, can I write 98 to 102? Yes, we can write. Why? This is not random family. This is limiting family. Limiting family means boundary will be there. We can write it. That's what the question. Next, R2 is equal to 50 plus or minus 1%. So 50, 1% of 50 is 1, people are saying. So kindly check your writing wrong also, people are saying. Come on here. 1% of 50 is 0.5. 1% of 50 is 0.5. What we can write now? 49.52. 49.52. 50.5. First, you get it in the procedure. Shortcut, I'll tell you later in the procedure. Okay. Right. Sir, concentrate. I want to find out R total true. R total true. Right? R total true. Again, people are asking, sir, how limited, sir? No data is given related to error. I repeated almost 10 times. 11th time I'm repeating. Error with respect to true value. Error with respect to true value means limiting form only. Limiting form means boundary form only. Suppose if I mention this as probable or something, that is randomly changing, no limit, but nothing is given means error with respect to true value. Any error with respect to true value defined as which value? Percentage relative static error, percentage limiting error. That's what it is. Okay, now come to this. Sir, R total true value. R1 true value, R2 true value by R1 true value plus R2 true value. Sir, what is R1 true value? 100. R2 true value 50. Substitute 100 into 50 by 100 plus 50. You will be getting 33.33. Oh, okay. Sir, R total true value we got it. But what we require? Error also we require. So that's why now I'm finding R total measured. But I'm finding R total measured two values because I'll tell you R total measure. Sir, R1 measured into R2 measured by R1 measured plus R2 measured. But sir, in this lower side measurement is there, higher side. Why? 100 minus 2 is there, 100 plus 2 means below 100 is there, above 100 is also there. That is the reason why I'm taking two things. Here I'm taking higher side 100 plus 2, 102 into 50.5. Why? I'm taking higher and higher. Means positive error side I'm taking. Okay, right now by 102 plus 50.5. Lower side 98 into 49.5 by 98 plus 98 plus 49.5. Okay, don't worry. I know the values, I'll give you. If you simplify this, you will be getting 33.77 ohm. You can verify also. And if you simplify this, you will be getting 32.88 ohms. Okay, right, sir. Now I want to find out the error. What is the error? Measured value minus true value by true value. So therefore, what is, what is that? 33.77 minus 33.33 by AM minus 80 by 80 into 100. Okay, in the same way, second case also same thing. 1 second. Right? Okay, sir. Here, measured value is 32.88 minus 33.33 by 33.33 into 100. AM minus 80 by 80, AM minus 80 by 80. Sir, large minus small, you will get plus. Small minus large, you get minus because less than 100. So minus. More than 100 plus only. If you simplify this, you are getting 1.3333 like that. 1.34 we can take. 1.3333 like that. 1.34 approximately. Okay, percentage. Sir, here also you will be getting 1.34%. Okay, now finally I'm giving that. Finally I'm giving therefore R total is equal to, what is the R total true value? 33.33 plus 1.34 or 33, no problem. Or minus. So this is what the answer of each and every parallel equivalent value. In this, there is no shortcut, there is no blind logic. Complete procedure based I have taken. What I have taken? True value I have taken. After that, measured value higher side I have taken. Measured value lower side I have taken. Then error higher side, error lower side. Simply is 33.33 plus or minus 1.34%. But here people are getting one doubt. Sir, if we get different value in both the cases, this value, both are not same, what we have to do? Come on here. Come on. If both are not same, listen carefully. If both are not same, we cannot write like this, no, sir. Then what we have to do means concentrate. If both are not same, check your calculation. Mistake might be there in the calculation because you should get both are same. Sir, why? Check it. 100 to 102. 2 difference. 100 to 98, 2 difference. 50 to 50.5, 0.5 difference. 50 to 49.5, 0.5 difference. Means both are equidistant from 100 or not. Definitely you should get same value. Suppose by mistake if you are not getting same answer, kindly go back and check this entire mathematical solution. That's why definitely you will get it because 100 to 102, 100 to 98, both are equally, therefore definitely will be there. Right? Every question, yes, it will be. Come on, don't ask the question like, sir, every question will be same or not. Every question will be same. That only I'm saying. 100 to 102, 100 to 98. Are you taking equally or not? Equally, it will be same. It should be same. If it is not same, you are wrong. Somewhere else calculate it. Okay, this is what the procedure. But sir, this much of time will be there in the exam. 2 marks question only. But this much of time will be there? No. That's why shortcut. So what is a shortcut? Concentrate. So what is a shortcut? Concentrate. Here, R total is equal to R1, R2 by R1 plus R2. Okay, right, sir. What is R1? Right, as it is 100 plus or minus 2%, 50 plus or minus 1% by. So many people may be having the doubts. All those will be clarified in this solution. And R1, 100 plus or minus 2% plus 50 plus or minus 1%. You write it as it is. Now check it. Sir, multiplication is there. Percentage form of errors. Yes, our rule is satisfied. Our rule is satisfied. Kindly check it. Answer will be same only. You only check here from your side 1.33 or 1.34. Approximately you will get. Both values are same. Undoubtedly you will get. You verify. Okay, next. Sir, 100 into 50. 5,000 plus or minus 2% and 1% added by multiplication is there. Percentage errors are there. Yes, mono correct. Same only will be there. Multiplication is there. Percentages are there added. Clear? Normal earlier procedure only. Sir, addition is there. Addition is there. But percentage is there. No. Addition, what we require? Value form means one step extra. That is 100 plus or minus 2% of 100 2 plus 50 plus or minus 1% of 50.5. Now, numerator as it is 5,000 plus or minus 3% by, sir, addition is there, value form. Addition is there, value form is there. Happy. 150 plus or minus 2.5. 150 plus or minus 2.5. 2 plus 0.5. Errors must be added. Okay, sir. Which operation is there here? Which operation? Division operation is there. Division means what we require? Percentage form we require. Yes, therefore, sir, 5,000 plus or minus 3% by. Here, this must be converted into, again, percentage form. Why? Division means, already told you, multiplication or division, percentage form. Addition or subtraction, value form. So therefore, sir, 150 plus or minus 2.5 is dash percent of 150. 2.5 is dash percent of 150. You will be getting 1.66%. 1.666 will be there. 1.66 or 1.67 as you wish. No problem. Correct. Mano, Prajeet and Amit Vikram. Yes, everyone correct. Now, sir, division is there. Now, everyone concentrate. Before answering this, kindly focus on this. Which case? Special case. This is special case when parallel resistors, parallel inductors, series capacitors are there. That is special case. So, in the special case, in the shortcut, what we have to do? Concentrate. 5,000 by 150, no problem. 33.33. But sir, you told that. Yes, I only told. No problem. Sir, percentage errors when the division is there added. Okay, let me add. What is that? Right? Sir, if you are framing any shortcut, that answer should be similar to the procedure answer or not. If shortcut answer is not matching with the procedure, which is wrong. Procedure is wrong or shortcut is wrong. If the shortcut answer is not matching with the procedure is wrong or shortcut is wrong here? Shortcut is wrong. So that's why in this special case, this is wrong. When parallel. So that's why what you have to bring, we need to make the shortcut such that procedure answer should be there. That's why 33.33 plus or minus. Here you take the difference 3 minus 1.66%. This is correct. Now check it, sir. If you frame the shortcut like this, is it correct or not? Check it. 3 minus 1.66. Yes, 1.34. Our shortcut is correct. That's why for parallel combination, a separate shortcut is required. Normal shortcut is not suitable for parallel. That's why separate shortcut, which is satisfying the procedure. That is in the last step. Don't add the errors, only subtract the errors. Now we can correct 3 minus 1.6 means 1.34. Clear? This is what the procedure. That's why special case procedure I gave you. If you are having the problem with shortcut, leave it. But procedure already gave you. Follow the procedure. But if you follow the procedure, unnecessary more and more time will be consumed. Why to waste the time? Simply go for the shortcut. That's why I know the point here is, sir, In your mathematics, in your +1, +2 level, you written one entrance, no? In that entrance exam, mathematics exam, so many shortcuts you have studied. All shortcuts are same? No. For given question, one shortcut. For given condition, one more shortcut. Like that, shortcut must be according to the procedure. According to the procedure. Right? But see, Saujanya, very good. Saujanya, very good. But sir, capacitance means series connection. All I told you here. What is it? Parallel connection of resistors, parallel connection of inductors, series connection of capacitors means what I want to say is R1 R2 by R1 plus R2, L1 L2 by L1 plus L2, C1 C2 by C1 plus C2. When you will be there, when you will be having C1 C2 by C1 plus C2 is not for parallel, for series. That's why this type of formula in our electrical engineering, where it is possible, parallel or parallel L, series C. In those cases only follow this reverse shortcut, reverse way of shortcut procedure. So, Janya, clear? Right. If option value is nearby, we may go wrong. Option value will not given nearby. In that way, they will give. No, not to worry. Right. Sir, but shortcut answer, positive answer is not exactly same. Why not exactly same? Check it here. 33.33 plus or minus 1.34. This is what the answer in the shortcut. This is what the answer in the procedure. Both are same. If you are getting different, something wrong is there in this calculation, you might have to check it. You can check it. 1.34, 1.34 only. 3 minus 1.66 means 1.34 only. Both are correct only. Both will be, both should be correct only. Don't worry. So this is the total lengthy chapter that is called as error analysis chapter. Lengthy chapter, various models of questions, various number of questions also we have solved. Clear, guys? Everyone clear? Clear or not? Right. Now, people's general doubt is, right, okay. People's general doubt is, right, in the shortcut method, every time do we need to subtract means based on the question parallel is given, then only. I don't understand my topic. Special case, if this special case parallel R, parallel L, series C is given, in the last step you need to subtract. If any problem is there with the shortcut, think like, sir, I have not explained the shortcut, leave it, follow the procedure. Because you are not understanding my shortcut. No, that's I'm saying, that follow the procedure. That's it. Very good. Shiva Gopi Raju, very good question, sir. Every time both answers will be same only. So why to find out two? Actually, I need to explain where concept and to explain higher side, lower side. I have calculated, but in the examination to save the time, if one you are calculating, enough, no problem, no problem. Because both will be anyway same. But explanation purpose, I need to explain everything to you. That's why I have taken this. Okay, right. Now, general common doubt is here. Concentrate, sir. 100 plus or minus 3, 50 plus or minus 2, something is given. These are standard deviation, for example. I gave the already question. And so this is I1, this is I2. I'm finding I1 plus I2, so and so dash. This was the question. Everyone understood, but only one or two people maybe having the doubt like, sir, how this standard deviation came into picture means try to understand the concept. Sir, I1 experiment I'm taking. Instrument, I have given X. Be clear, I have given X. I observed 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times. I observed some value. I have taken the average value of all this. I got 100. That I have given here. Okay, what is it? I1, they are conducting the experiment in the random different values 10, 20, 30, anything. I experimented here. I have taken the mean value, true value 100. After that, deviations D1 to D10. After that, standard deviation I calculated. I got the standard deviation as 3. So therefore, this and this given in the question directly. That's why there is no question of n minus 1, n plus 1, nothing is it. Because after the experiment, they have given that 100 is the true value they observed in the random error analysis. 3 is the standard deviation they observed. In the same way, second experiment, I2. Instrument is being taken 1, 2, 3, 4, something. Mean value they have calculated. They got 50. I gave here. And deviations D1 to Dn, standard deviation they have got 2. That is what the experiment. Clear? Right now, I'm taking the various number of questions. Be ready to answer. Be ready to answer. Right? Various questions I'm taking now. Now it's your turn. Now it's your turn. Dinesh, sir, probable error is 0.6745 times of SD, but in questions both are taken as same. Where? Go back and try to analyze the topic. I have not taken that. Go through that once. Go through that. What is the answer? Very simple. Without moving your pen, you can answer if you understand my topic. So far, what I have taken. Be clear, sir. A large number of 230 ohm resistors are obtained by 120 with a standard deviation of 4, 110 with a standard deviation of 3. So therefore, first, what is the given data? Concentrate. What is the given data? What is that? R1, for example. 120 plus or minus 4. This 4 is standard deviation, right? R2, 110 plus or minus standard deviation as 3. He is asking total resistance. What is that? R total is equal to R1 plus R2. Sir, 120 plus 110, 230 common. But he is asking standard deviation of 230 ohm resistance, means plus or minus. This is what the value. This is standard deviation you require. What is the procedure here? I told you, no. Shortcut, you can say, what is the answer here? 5 will be there. This is what the answer. Right. Yes, everyone has given the correct answer. Correct. Yes, correct. Very good. Very good. Very good. Right. Next question. Right. Whatever the experimental example just now I gave you, this same thing elaborately explained. I will explain constantly. Everyone, don't write anything. Kindly. A voltage V1 is measured 100 times and its average and standard deviations are 100 and 150. At least now clear or not? So therefore, in this question, clearly they have given V1 experiment they have done 100 times. They have taken the mean value, that value as 100, and they observed deviations and standard deviations, that is 1.5 volt. Okay, same thing, experiment I gave, like this. Experiment they have taken true value and standard deviation they have given. Next, in the same way, second voltage V2, which is independent of V1 separately, he is measured 200 times. That is his wish. Simply, what is that? V2. How much value? True value, average value 150 plus or minus deviation is 2 volt. Deviation is 2 volt. This is what the point. Now he is asking V3 is equal to V1 plus V2. Then the standard deviation in V3 he is asking. Standard deviation in V3 he is asking. This is what is the numerical answer type question. What is the answer now? Simply standard deviation in V3 is equal to, just I'm giving the step here, root of V1 to the power 1 into V1 error is 1.5 square plus V2 to the power 1 into V2 error 2 square, right? And here 1.5 square 2.25 plus 2 square 4, 6.25 root means 2.5 volt. You can write plus or minus, but in the answer 2.5 value. Yes, Abhijit, is it percentage or value? You are given 2.5%. No, yeah, it is value, directly value. Clear? Right. No. One more question, right? One more question. I told you, no, many questions I will take. Step by step, we'll get the terminology. Okay, Abhijit, correct. Right. Right. I'm giving 2 to 3 minutes of time. I will see whoever give the correct answer. Point 13, 13.13. People are saying that, sir, I did not understand power means. P equal to V into I. What is the V power here? 1. What is I power? 1. P equal to I square R. What is I power? What is I to the power? 2. That only I told. Different answers. Okay. Try. People are giving 0.12, 0.13, 13. Okay. 2 different answers. Omkar Gaikwad 0.12. Yes, Ayush 0.12. Okay, different answer. Vishal. Okay. Stop answering. Stop answering. I will do it. Kindly, I'm requesting everyone. Stop answering. Right. Which is correct? I'll tell you. Kindly, I'm requesting. Stop answering. Right? Okay. Very good. So we will responded correctly. Yes. Now I'll do step by step. Sir. Prashant, I told you to stop answering. Kindly concentrate. I will give you, then you can answer. Right. See. The resistance of a resistor is measured using a voltmeter ammeter. Okay, V by I model. The voltage measurements have a mean value of 1 volt. So V is equal to 1 mean value. Standard deviation of plus or minus 0.12 volt. While the current measurements have a mean value of I is equal to 1 milliampere. Plus or minus standard deviation of 0.05 milliampere. 0.05 milliampere. Okay, right, sir. Assuming that the errors in voltage and current measurements are independent, the standard deviation means the both errors are not the normal errors, not the normal, both errors are standard. So that's why these are given as standard means random family of present topic only, right? The calculated resistance value is dash resistance value. Which one? Standard deviation of resistance he is asking. Okay, very simple. Yeah, very simple, sir. You can do by procedure, you can do by shortcut as you wish. Now I'm taking, sir, here V is equal to 1 plus or minus 0.12 volt. Value form is given. But what he is asking? R is equal to V by I. V by I means, okay, division, shortcut. Division means what is a shortcut here? Percentage errors are required. So that I'm converting this. 1 plus or minus 0.12 is dash percent of 1 year, 12%. First thing. Second thing, I is equal to 1 milliampere plus or minus 0.05 milliampere. Sir, 1 milliampere plus or minus, sir, 0.05 is dash percent of 1 milli. 0.05 milli is dash percent means 5%. If you understand this, thing will be over. Okay, right. Shortcut I'm giving. I'm using shortcut. R is equal to V by I. Okay, resistance is equal to, sir, V by I, 1 by 1 milli. So therefore 1000 ohm is common. True value, no problem. Only error is confusing. Yes. So therefore, what is it? Resistance, standard deviation resistance. What is the shortcut I told you? Root of voltage. How much power is there? 1 into. Sir, what is the voltage percentage error? 12. But keep the percentage outside. Square plus. What is I power? What is I power? 1 into. What is I percentage error? 5 square. So therefore, what's the answer here? 12 square 144, 5 square 25, 169. Root means plus or minus 13%. Plus or minus 13%. So therefore, 100 plus or minus 13%. But value form 1000 plus or minus 13% of 1000. What is it? 130 ohm. In the examination, what you have to type here? This one. These two are standard deviation only, but 130 because he has given that value form representation in terms of ohm, not percentage here. He is asking in terms of value form because how do you understand means percentage symbol is not given, ohm symbol. So therefore 130 ohm. 13 is a percent, 130 is a value. So therefore those who are given 130 value correct, 13% also correct, but other people are given have given different answers. This is the procedure. What is that? Shortcut notation. Directly you can write gate 19. No, that is what gate shortcut is sufficient. I'm doing this, but I'm giving the homework again. Do by procedure. What is it? Taking the partial differentiation and all. Do by procedure. See, in the shortcut I told you, division operation is there. Division operation is there. If they have given percentage already, no need to convert. But which is given? Value form is given. Convert that into percentage because what is a division operation here? Which you require percentage form. Given, not given. So therefore, converted that I told you. That I told you. Sir, in sigma formula, you have not substituted value form. This is the shortcut. This is the shortcut. This is the shortcut. So, clear, got it. People are still so many doubts. See, I am understanding you. Where you are getting confused means What is that? Value form to percentage. Percentage to value form. Many people are getting confused. One student is asking that, sir, don't we need to consider milli? I considered here. I have considered 0.5 milli is dash percent of 1 milli. 0.5 milli is dash percent of 1 milli. 5%. 5% plus. And people are saying that, sir, how the 1,000 is coming? What is this here? 1 ohm by 1 milli, 1 volt by 1 milli, 1 by 1 milli, 1,000. That's what we got. We have considered millis. We have considered millis. Concentrate. Clear? This is the corresponding procedure. Okay. Right. Divya Balaji, I told you in the day before yesterday class, shortcut, multiplication or division percentage form. So many times I told you, I'm repeating, don't worry. Multiplication or division percentage form. Addition or subtraction value form in the shortcut process. Clear? Srinaya. Okay, sir. Thank you. Clear, sir. Right. Okay, right. So this is the total discussion regarding all types of questions in the corresponding error analysis. Right? In exam pressure, we forgot. In the exam pressure, we forgot means not only this, everything. So you should not forget even under the tremendous pressure means you should have the good practice. You should have the good practice. Very good. Imtiaz Pasa, very good. Now only I did wrong. Yeah, that's what. That's why you need to have more practice. Very good. Very good. Try to understand like that. Clear? Right. One more question. Right. Okay. Bhavana, very good. Bhavana, very good question. I'm answering. Sir, we got 13% and 130 also. No. If we give only 13, do we get the mark? Means no, because he has given ohm symbol here. Ohm symbol means value form he is asking. Suppose if nothing is given here, then nothing is given here. You can keep in value form 130 or you can give in 13% also. But in this ohm means value form only. Suppose if they have given percentage symbol, then 13%. If nothing is given, suppose if nothing is given, you can give any representation. But in this ohm is given, ohm means value form. That's why everyone should give 130 ohm only. Because if you give just 13, they will think that 13 is a value form. Wrong answer only. Same mistake many people did in the 2019 and they called me and told that, sir, I kept it 13. Will it be, the mark will be given? Definitely no. Definitely no. Right. Right. Bharati, right. In procedure form, multiplication or division or subtraction or addition, always, which one here? Value form only in the procedure. Yes, very good, correct. Bharati, yes, I'm correct. Right, do this. Very simple. Sample standard deviation he's asking. What you have to do? First, mean x bar 5.9, 5.7, 6.1 by 3. How much is the value? Mean value? Approximately 6, 12.7. What is the mean value, guys? Okay. Okay, everyone is giving that 5.9. Okay. Right. Stop giving the answer. Kindly, I'm requesting. Right. So 5.9 is the mean value. Okay, after that, deviation 1. What is that? X1 5.9 minus mean value 5.90. Deviation 2 5.7 minus 5.9, that is minus 0.2. Deviation 3 6.1 minus 5.9, that is plus 0.2. Okay, now standard deviation formula. What is that? Root of d1 square 0 square, d2 square minus 0.2 square, plus d3 square plus 0.2 square by, be clear, it is less than 10. No, n minus 1 means 3 minus 1. Don't take 3. 3 minus, you will be getting 0.2 as the answer. That's it. Yes, very good. Yes, everyone give the correct answer for this. Very nice. So this is the total discussion for related to the entire error analysis. Okay, right. Now, sir, Shirisha, correct. Right. Now, this is the complete chapter. I have done so many various questions. Whatever the question booklet available in the OTS platform, you practice all questions. I have done almost all we have done. Right? You practice those questions again and again, right? Right. Standard deviation, probable errors are always positive or negative. Generally, error no, yeah, plus or minus we can take. Error means plus or minus. No need to write always positive. That's why I told you 100 plus or minus 4, 50 plus or minus 3. Standard deviations plus or minus will be there generally, because error notation no, always we take like that. Right. Here also I should keep plus or minus, but in the options it is not there. No, no need to worry. That's what simply. In the shortcut, I'm repeating almost 20-30 times I told, still people are asking. In the shortcut process, addition and subtraction value form, error may be standard, probable, random, anything. Yes or no? In the shortcut, addition and subtraction value form. In the shortcut, multiplication, division, percentage form. I told many of the times I'm repeating. Can you note this? Right? Okay. Now I'm taking the next chapter, introduction, so that Sunday we can complete this entire thing. That is what? Basic instruments. Basic instruments. Again, complete concept. Now we are entering into the instruments. So far we are taking basics of measurement, that error analysis. Now I'm taking instruments. Generally, instruments are classified into two types. Instruments are classified into two types. What are those? Means one is primary instruments. Primary instruments. Other one is secondary instruments. Primary instrument and secondary. These primary instruments are also called as absolute instruments. Primary instruments are also called as absolute instruments. Okay. And examples for these are tangent galvanometer. Tangent galvanometer. I'll tell you what about this entire thing. And secondary instruments are again divided into three types. One is indicating instruments. Indicating instruments. Second one is recording instruments. Concentrate. Recording instruments. The third one is integrating instruments. Third one is integrating. This is the total instruments classification: indicating, recording, and integrating notation. Right? Okay. Now, sir, indicating instruments. What do you mean by indicating? Everyone concentrate. Definition will be given later. No problem. Indicating means the instruments which indicate the value at the time. Means whatever the equipment, whatever the instrument in your laboratory you have used. In your laboratory, whatever the device you used, ammeter, voltmeter, wattmeter, etc. As long as the supply is given, come on guys, as long as the supply is given, the pointer has shown the value 2, 3, 4, etc., etc. The moment supply is 0, it has gone back to the supply is removed, the pointer has gone back to 0. Means these are the instruments giving the value, showing the value at that instant of time. That's why technically we say these are indicating instruments. Technically we can say indicating instruments. These are just indicating instruments. Just indicating instruments. Example. Everyone knows that ammeter, voltmeter, wattmeter, etc. Okay, right. Next, sir, recording instruments. Sir, what do you mean by recording? Means the instrument has the recording facility. The instrument has the recording facility. Means, see, in these instruments, do we have any recording facility? No. Why? Means instruments show the value. We will record. Human being will record in the notebook. But in these instruments will record. Means suppose 1 hour we are operating. Throughout the 1 hour, whatever the variations are there, all those will be graphically recorded by the instrument that is called as recording instruments. Recording instruments. The examples are ECG. Examples are ECG. If you are going for heart checkup, ECG is there. No, during that 1-2 minutes of time, what is our heart status and all graphically represented. Or XY recorder, we can say simply XY recorder. Okay. Other than that, one more best example is seismograph. We can say seismograph. What is seismograph? Earthquake measurement. Earthquake measurement. As you know, that is what recording. That is what recording. CRO also coming under this, but CRO is a digital type of device, that is separate category. Any graphical representation is there, that is coming under recording type. CRO also called as recording, but in that some other feature is also there, that is digital. That is digital. That's why I'm not giving here. These are the example. Means during the operation of 1 hour or 2 hours or 3 hours of time, it will be giving the graphical representation. Giving the graphical representation. So therefore, yes, we can write recording instruments. You are not understanding my statement. In the CRO, recording facility is there. Something else is also there. That why I'll be taking that example later, I told you. But immediately, so in our laboratory, we have taken, I already told you, CRO, okay, I'm writing for your idea purpose. Satisfied? That's why let me explain the topic clearly. Now, integrating instrument. Integrating instrument. Sir, integrating instrument means, what is it? Integrating means during a time of operation, all the values must be combined. All the values must be summed. All the values must be summed and shown. That is called as integrating. Integrating means, normal meaning integration. Integration means cumulative summation. That device is called as energy meter. Whatever the meter we have in our home. Yes, Saujanya, correct. Namrata Dipti, correct. Energy meter. That is what example. And one more is also there. That is charge meter, or we can say ampere hour meter also we can say. Ampere, current, hour, time, current into time, charge. So charge meter also we can say. This is simple introduction only. But after that, what is primary, what is indicating, what is recording, what integrating, everything I'm going to elaboratedly explain in the next class. That is on Sunday 2 o'clock. Tomorrow is a break. Kindly properly for the notes. But these topics not yet started strictly. Only introduction I gave you. What is primary, etc. etc. Lengthy discussion is there. I will give you everything. No need to worry. I will give you everything. No need to worry. Clear? Okay, I'm stopping today's session. Now, let us have the doubt session. If any doubt is there, kindly let me know. Indicating instruments will be explained later. Only introduction I gave you. Except this topic, you can ask other doubts because this will be continued in the next class again. Don't worry. Any doubt, you can ask me.
Hello.
Yeah, tell me, Abhijit.
Sir, in standard deviation formula, we have decided finite data system and infinite data system based on 20 or 10.
I'm not understanding. I'm not understanding.
We have written two formulas. Say, in one, in denominator n is taken as a n, and in
Kindly
other.
increase your voice. I'm not at all able to listen your voice.
Hello, am I audible, sir?
No, not audible clearly.
Hello.
Yeah, tell me. Hello. Tell me.
Hello.
Yeah, tell me.
Sir, in standard deviation formula, we have taken two systems: infinite data system and finite data system.
Yeah, yes.
The n value is 20, less than 20 or less than 10. We have taken
Less than 20 only. What I gave you, less than 20 only.
Sir,
Less than 20 only. This is a formula. But generally in the questions, 10 will be given, I told you. But less than equal to 20 only. But in the practical examination point of view, they will give only 10 values they will give, I told you. But less than or equal to 20 only.
Sir, then in homework problem, if we taking denominator as 10 minus 1, then
don't mind little bit louder. Otherwise, I'm not able to understand your voice.
Hello.
Can't you speak more louder?
Sir, I am speaking louder only.
Yeah, tell me.
In homework problem, if we taken denominator as 10 minus 1, then answer comes to 0.233.
Okay, I gave the homework question, right?
Yes.
This one, yeah.
Then standard deviation comes as 0.233 when we are taking
0.233. 233.
Yes.
233. Okay.
Yes,
approximately yes. I gave here nearby value, you choose it, not exact answer actually. 0.221, 0.223, like 0.23, like that. No problem. But, sir, you should take n minus 1 formula only because it is less than or equal to 20.
Then probable error value get different as 0.15, sir.
0.
All the value 15.
15. Kindly check it once again. Check once. I will also check. But generally, I hope these are the correct answers according to my knowledge. Just check once again. I'll also check it. No problem.
Okay, sir. Thank you.
Right. Anil Kumar.
Good evening, sir.
Yeah, good evening.
Sir, I have a doubt in if errors are in standard deviation and probable errors, random errors. Sir, I have a doubt in if errors are in standard deviations. Second problem, sir.
Voice is not clear.
P equal to VA.
Yeah,
sir,
yeah.
If errors are in standard deviation and sir, in second problem, sir. Next slide, sir. 17F.
Which one?
Next slide, sir. Hi, sir. This one, sir. Sir, in this, we were told that last classes.
What are you asking? Not getting.
Sir, 17F.
What is your doubt?
17F, sir. Slide number 17F. Okay, sir.
Hello.
Yeah, tell me.
Sir, good evening, sir.
Yeah, good evening.
Sir, my doubt is that to find the standard deviation or that uncertainty of random errors, you have given one formula, square root of dou by dou, that if you have given us.
Differentiation square. Okay.
This formula is clear to me. If the equation is like y equal to x plus 2y by z plus 7y,
those
like
type of question, yes, good question. Those type of questions will not be a gate level or ESC level questions. Don't worry.
Okay. Yes, sir. Okay. It's fine.
You are asking associated law in that way, right?
Yes, sir. Yes.
Those type of questions will not be given
it's
at
having
level.
Both addition and multiplication, 2 terms or 3 terms.
That's what I'm saying. Those type of questions will not be given in the BTech level, graduation level. No need to worry. Otherwise, even if you want to have that solution, simply R1 R2 by R1 plus R2. For example, R parallel is there. All errors are given standard R, probable R, random R, uncertain. For example, same procedure. Dow R total by dow R1 differentiated. Partial differentiation will become very lengthy, right?
Yes.
That's what those type of questions will not be at graduation level. That too, in the objective paper, they will not ask. No need to worry. That's why I told you, parallel type, these type of questions will be there in the ESC conventional model. We will take in the ESC conventional exam because there, this is 12 marks question, 18 marks question, 20 marks question will be there. I will take that. No problem.
Sir, means
But one second,
method.
one
Yes,
second,
sir.
one
Please,
second.
please.
Method is same, but sir, I'm facing the problem in partial differentiation. Means as a measurement faculty, I cannot do
No,
anything.
I know mathematics
No, not
a
you,
bit, sir.
generally.
Okay, okay.
Yeah. Tell me.
I know mathematics, sir. I've solved problems on partial and differentiation
Then
all.
very good.
That's
Very
why I'm asking if
good. Yeah.
in that we
Same
have
procedure.
equations like that, no? The same
Yeah,
procedure.
same. Yeah, very good, very good. If you are perfect in the mathematics, I will be very happy because it is easy for me. That's why procedure is same, but it will be lengthy. That you have to concentrate. But while you are taking this much lengthy is there, it may be wrong. No, same procedure, lengthy will be there. That's correct.
So please go back one page. Just
Go
now
back.
shown that formula, na, sir.
Yeah.
Sir, in the between those two terms in that under root we have two terms, na, sir.
Yeah.
If we
This
have
is one.
similarly 3 terms or 4 terms in addition, subtraction, multiplication, division,
Definite addition.
plus only.
Plus
for all.
only. Very good. Plus only.
Thank you, sir.
Right.
Sir, one more, sir. Sir,
Okay.
in errors we have the topics which are difficult is one this uncertainty and second is that limiting error. Only two are means up to some conceptual. Remaining all are just we can write. Only those two difficult, na, sir.
Yes. These only numericals actually. In the error analysis, limiting and random only more numericals, but it is not tough at all. If you follow my statements and my rules clearly, things will be clear. But what not only you, Mubin, generally what people are doing now, if I say that x plus y, people are not taking x plus y. Sir, x minus y is there, what happened? They're thinking in that way.
Okay.
That's why you will face the problem. That's why once I say x plus y, first you solve it. Then I'll go to x minus y. I'll go to x into y. I'll go to x by y. But the problem is, I'm saying A, I'm saying alphabet A, you're going to APPLE apple and getting confused. I cannot do anything.
Yes.
That's what, not you, generally.
Yes, sir. One more request, sir.
Yeah.
Sir, that you have given all the CRO questions you have solved in classroom itself, sir. Just now I have gone through this paper. So
Yes.
if you have any further questions on these topics, any extra questions? I mean, I've checked
I will try to provide. Actually, from these questions, only few questions must be solved. But generally, my way is I'll solve almost all the questions to give that.
Thank you very much, sir. But if we have any one or two unknown questions, then we can. I
will try to. But my request is, even after the class, you practice the same questions again. I'm requesting so that you can get. What is it?
Yes, sir. Yes.
Excel in that, right? Okay.
Thanks.
Hello, sir.
Dwarakesh?
Good evening, sir.
21F, sir.
Yeah.
21F, sir.
Hello?
Hello, sir. Audible, sir?
Yeah. Tell me.
21F, sir.
Yeah. I opened.
Sir, in that relative form, I am not understanding, sir.
Did you attend my yesterday's class, day before yesterday's class?
Yes, sir. But this step I am not able to understand, sir.
Why? Where you are not understanding? Yeah, you tell me the point. I'll explain that point.
That why you are multiplying and dividing it by a square, sir.
What is the formula?
Rho L by D square.
Rho into L. Product is there, right?
Oh, okay, sir. Okay.
Taking the product. D square is there, right?
Yes, sir. Yes, sir.
That only I have taken.
Okay, sir.
Sir, in 8F, sir.
8F.
8F.
Yeah.
Sir, in this, we got E1 is equal to minus 0.72 and E2 is equal to minus 1.2. Among these two values, E2 is low value, no, sir, low error. But you said,
Come on. Okay. Don't apply your mathematics like, sir, this is minus 0.7. This is minus 1.2. Not like that here. Our thing is what? Negative is only the nature. Negative is only the nature. 1200 ohms error is there. 720 ohms is there. But as the measured value is low, what is that? Error is become negative, but don't think like your mathematics, sir, this is low, this is high. Not like that here. Magnitude. I told you in the starting class, based on the nature, error may be positive, error may be negative, but we need to concentrate only on the magnitude. Clear?
okay. Okay, sir. Sir, again 5F, sir.
5F. Yes.
Sir, here I understood how we got R is equal to 3.6 kilo ohms, but here you said voltmeter has infinite resistance, sir.
Yeah.
Could you say it again, sir? Due to network issue,
Okay,
I
see,
missed it, sir.
Voltmeter has infinite resistance means I have opened the corresponding voltmeter. Means in the voltmeter there is no loss at all. There is no power consumption at all because it is open circuit. Means if it is open circuit means ideal case. Ideal case means I have written true. Simple, you miss something. What is it? Voltmeter is there, but I'm not showing means voltmeter is open circuited. Open circuit means ideal case. Ideal means true value. Only that's it. Nothing more than that. If you come here,
Okay, sir.
voltmeter is finite, practical. That's it.
Okay.
Vaishnavi, clear?
Yes, sir. Clear.
Okay.
Hello, sir.
Yeah, tell me.
Sir, 20th.
20F.
Yeah, slide number 20th.
Yes.
No, sorry, sir. Actually, that question R is equal to 4 rho L.
Yeah, this one. Yeah.
Yeah, this one. So, sir, in second, you said you used the shortcut method, no? Like under
Yes.
root. So,
Yes.
my problem is this method is only applicable for random error.
Which method?
And the shortcut method you said, na, under root, we are taking multiplication of power and
Root approach.
Yeah.
See,
Root approach.
yeah, you are missing something. See, I told you already. See, this is the procedure, root approach. Either procedure or shortcut. For which one here? For which one?
LSTP. Okay, RE uncertainty. Yeah.
That's right. No problem. As a starting, confusion will be there, no problem. Clear?
Okay. Yeah, clear, sir. Thank you, sir.
Right.
So good evening, sir.
Yeah, Anil.
Sir,
Is it okay now?
yes, sir. If you
Yeah. Tell me.
Sir, I have a doubt in if errors are in the standard deviation in second problem, sir. Second problem, sir.
Second problem.
Yes, sir.
Yeah.
Sir, I have, you have said that in last class, if it is percentage, you have to, the value should be multiplied or divided, sir.
That only I have taken the shortcut, right? Percentages. For multiplication, I have taken percentage only in the shortcut. That only I have taken.
Sir, in procedure step, you have converted.
That's why I told you. You did not listen, I think. In the procedure format given by the Gauss theory is either multiplication or division or addition or subtraction, value form only. 5-6 times I have taken this statement in the class. What is that? In the random error analysis, procedure based approach, value form of errors only I made like this to be taken. But in the shortcut, all I told you, multiplication, division, percentage form, addition and subtraction, value form. That's it.
Sir, I have another doubt, sir.
Yeah, no problem.
The resistance of a resistance is measured, sir. So the resistance of a resistor is measured.
This one?
Last two slide before, sir.
Oh, last two. Okay. This one?
Yes, sir. And I have a same doubt in this problem, sir. V equal to, they have given that 1 plus or minus 0.2, sir, but you are taking that converted to percentage, sir. You have said that
That's
now
what I'm telling you, sir.
uh,
Division one second. Division operation, shortcut. What I require?
okay,
Come on.
sir. Okay, I understood, sir.
Procedure. With that only please
Sir,
link
sir,
action. Right.
okay, sir. Suppose we are solving through the procedure method means we are taking into same
Value
format.
forms. Value forms.
We are going to shortcut method.
See, simple logic here. If you want, one second. If you want to go by the procedure method, value forms always. If you want to go by shortcut method,
Okay,
multiplication or division percentage form, addition or subtraction value form. That's it. Right? But do by this procedure means for practice purpose I gave you. Did you do, Anil? Anil, by procedure did you do?
Sir, that problem you have given some.
Did you do?
Yes, sir. Yes, sir. I am doing.
Got
Sir.
the answer
That
same?
only I have missed. Yes, sir. Yes, sir. I am doing, sir.
Okay, you are doing. No problem.
Sir, I
No
have
problem.
different. Got different answers, sir. That's
Means some mistake is there in that. What is it?
okay.
Differentiation or something, etc. You check it once.
Point, sir. Okay, sir.
Right.
Thank you.
Okay. Vallupalli Srikanth, is this sufficient for gate? Definitely. But extra question you try to practice. That's it. Extra question you try to practice. See, whoever the doubts are clarified, kindly raise your hand from your side. Kirti, unmute from your side. And Jaya Krishnan, sir, 31F. He has typed the message 31F. This one, same thing I explained for other student. Okay. No raised hands right now. Sir, in random error analysis, SD and probable error are for calculating errors only. So which one is accurate? What is that? What is this question? Pranay Raj? Question is not correct. Right. Sir, Yogesh Gaikwad, 29F. Is it Yogesh? Right. Shivanath Ganesh, even if you are getting different answers from high and low means calculation mistake is still check it. Still check it. Shirisha 2 to 830. Right. Yogesh. Yeah, what is the doubt in this? See, 120 plus or minus 4 is standard deviation. 110 plus or minus 3 is standard deviation. Simply standard deviation of R total root of R1 to the power 1 into R1 error square, R2 to the power 1 into R2 error 3 square. So therefore 5. You have done no, yes, so many times that only. Okay. Soundarya Vishlavat, Soundarya, last slide. This one. Primary and secondary I will explain later. Only I gave the corresponding, what is the introduction only I gave you. Don't worry about this. Yogesh, thank you. Welcome, welcome. Soundarya, no need to worry. I'll tell you later. No problem. Right. So can we limiting here? Worst case error means Saujanya. Worst case error means maximum possible waste error we say. That is what? Percentage limiting error only. Yes, correct. See, Imtiaz Pasha, I need to close the session. I need to send the file to the corresponding person. He has to make it PDF. That to class. I'm leaving the class by 9:30 approximately. He has to receive that message. And after that, he has to make it PDF. He has to upload. Definitely time will take. Okay. Saujanya, very good. Okay. Regarding the material and all, kindly call to the manager. I know everyone is having the manager number. Seshu, electrical people manager number. Kindly call him. He will give you the information regarding material. Okay, right. No. Actually, from my side only, Shirisha, my side only it was missed, I think. While erasing, this rough work will be there. No, while I was erasing this rough type of work, it might be missed, but it will not be done. No need to worry. Okay, then I'm closing the session. Tomorrow is a break. Kindly, definitely, it will not be missed here. Now, why do we miss here? We are here to you only. Why do we miss? Unknowingly, it might happen, I think. Right. Good night, everyone. Tomorrow is a break. So kindly, all this chapter, total chapter must be prepared and come to the class. Right. Midil Sharma, yes. Good night. Good night. Take care. Right. Thank you. Thank you so much.
Good night, sir.
Right. Thank you. Thank you. Right.